Hi students, welcome to ACE Online platform. As you all people know, the ACE Online is offering the mock test for the scientific officers BARC 2025. So already mock test 1 is done. In this video, you're going to find the video solutions for that test. And one more thing, so there are 4 more full-length mock tests are available. If you wanted to register for that, you can scan this QR code. So register for this online test series and improve your skills, improve your concepts and learn the time management and get the exam kind of environment. All the best. Good luck.
Hi students, welcome to ACE Engineering Academy and ACE Online. Myself, Professor K. Hanumantarao, faculty in Electrical Department. Now I am going to discuss about mock test 1, questions and solutions with the subject of network theory. Let me discuss one by one, right? Under mock test 1 network theory questions, as you know that under network theory, the main important topics are basics, transients, AC circuit analysis and two-port network parameters. The questions we may expect a more number under this. These are the strong topics under network theory. Let me take one by one. Right. The first question is related with two-port network parameters. The question is, determine the H parameters for the below network. Guys, if you identify this network is the combination of the two networks which are connected either series and parallel. Once you identify that, in this network, the input port is connected in series. Since you can identify that here V1, right, positive to negative. How much current is entering into this from the input port? Same current is should leave, and the same current is entering into the second network of input port. That's why I can say the input is connected in series. This is the first identification here. Input is connected in series. This is the first identification. Guys, once you see the second one, see that second one, first terminal of output port is same as, suppose this is, if you consider that as 2 and this is 2, 1 dash, right? And the other terminal 2 dash is connected with that here 2, 1, 1 dash. Is it right? That's why the output port terminals of one network is same as the output port terminals of the other network. Terminals are same means what? Potentially same. Potentially same means what? Both are connected in parallel. Both are connected in parallel. That's why I can say that output is in parallel. Getting, guys? And you have the idea regarding the hybrid parameters. When two networks are connected, input as in series, output as in parallel, the resultant entire network, total network, resultant hybrid parameters, simply you can add it if you know the individual network hybrid parameters. Is it right? As you know that for Z parameters, both are connected in series, Y parameters both are connected in parallel, can be added. And under H parameters, input should be series, output should be parallel. Series parallel connection can be added for resultant network hybrid parameters. To obtain that, here resultant network hybrid parameters by knowing the individual network hybrid parameters. This is, let me take this, the detailed solution for this one, right? See this one? Now the solution for this one, I can say, for series parallel connection, series parallel connection of two networks two networks can be added. What parameters? Hybrid parameters of individual for total network hybrid parameters. Total network hybrid parameters. Got it? Guys, he was given that individual network parameters. See this one. H1, suppose if we take this as a H2, this is H1 and this is H2, then I can take the resultant network ABCD hybrid parameters will be like this. Total network hybrid parameters or total network hybrid parameters, resultant network hybrid parameters, HT is equal to H1 plus H2. Now guys, take the individual network hybrid parameters. See this one, 1, 2, 3, 4. See this, 1, 2, 3, 4. And second network, 2, 3, 4, 1. 2, 3, 4, 1. Tell me guys, resultant network hybrid parameters. What we are getting? Resultant network hybrid parameters are here resultant network hybrid parameters H11, H12, H21, H22. Directly you can add it 1 plus 2, 3, 3 plus 3, 6, 2 plus 4, 6, 4 plus 1, 5. This is the final network, right? Complete network for the resultant network hybrid parameters. Resultant network hybrid. Let me see the given options. What are the given options? See this 3665. 3665. Option A is the correct one here. Option A is the correct one. Got it? Got the clear solution for this question? Okay. Let me consider the next example. Next question. See guys, what is the next question given? From this, the question is for the circuit shown in figure, determine the value of I. The current, where it is given, the current in 1 by 3 ohms resistor current you have to take it. 1 by 3 ohms resistor you have to take it current. And guys, if you see that this is under DC circuit analysis, and how many sources are given? 3 DC sources are there. Resultant current if you want to find out, usually guys you may get it, you go for the nodal analysis or mesh analysis, but we have so many simplification techniques are there. Out of that, if you see the which technique is suitable for this one to obtain that answer within the time, or if you want to get within the stipulated time without putting pen, we are going to answer this type of questions. That is, think without ink. I can say that. How you take it? Look here, by doing the one of the simplification technique, source transformation technique, with one step you are going to answer this question. Let me explain that. How you take it here? I can consider only one step here. See this, using what? Using what? Using source transformation technique. Once you see that source transformation technique here, see this one, a current source is connected in parallel with that resistance. That is the practical current source. If you are going to take that practical current source, you are able to convert in terms of the voltage source in series resistor. Then under that instant 10 into 1, 10 volts. With that, the polarities we are going to get it, this is negative and positive. Under that instant, after the modification, after the simplification of source transformation, you can identify 2 voltage sources are connected in series in opposite direction with the same magnitude. then definitely both the voltage sources will be cancelled. Resultant voltage is 0, but the two resistors are to be connected in series. That is why I can say 1 and 1 are connected in series, then 2 ohms. The entire combination of this, are you getting? The entire combination of this, definitely I can say that this total combination we are going to make as a 2 ohms resistor here. The entire combination we are going to make it as a 2 ohms resistor. Once you are able to define that as a 2 ohms resistor, only single branch by the simplification. If you are able to define like that, then under that instant you will get 2 resistors are in parallel, one current source is there. Now, if you want to identify this current, when 2 branches are connected in parallel, by knowing the resultant current, if you want to get that individual branch currents, we can use that current division rule, CDR. Once you recall that, then definitely this branch current is equal to total current into opposite branch resistance by sum of the 2 resistors. But before going to that, guys, once you identify the direction of the current source and the required current in the branch is opposing, not same. According to this current direction, the current direction which is existing in the 1/3 ohms direction is upward direction, but our required current is downward direction. That is why you need to provide that opposite negative sign. Now, let me take that the directly with only one step here. Just now I have given by CDR, current division rule, total current or I value is equal total current with negative sign, 5 into opposite. Opposite how much? After simplification, we are getting, after simplification, this entire branch as only 2 ohms resistor here. Just now I have provided. Now with this into 2 by 2 plus 1 by 3. Now what we are getting? Minus 5 into 2 is what? 10. 10 into 3 is what? 30. Minus 30 by 7 ampere. See this. Where it is minus 30 by 7, option B is the correct one. This is the way how you have to take in the examination. With only one step, I am going to get the correct answer. Right? Now let me take the detailed discussion about this one. How the simplification? By using the source transformation technique. Let me take that. Now, guys, the detailed solution I can provide here by source transformation technique, by STTR, source transformation technique. STT means what? Source transformation technique. Right. Now, the branch whatever we have taken here, first one, current source, practical current source in terms of the idea, this practical voltage source. This is the way how I can convert 10 volts 1 ohm. Rest of the network is as it is here. Rest of the network means what? 1 ohm as well as 10 ohms, positive to negative, 10 volts 1 ohm, and here 1/3 ohm. This is our required I, and 5 amperes current source is downward direction is given. Yes or no? Now once you see that here, both the voltage sources are in series with the same magnitude, both are opposing. That is why we can cancel these two here. We can cancel these two here. Resultant voltage source is 0. Nothing but what? The modification, after simplification, you will get that network as like this. Getting, guys? Now 1/3 ohms and 1 plus 1. This is what? 2 ohms. Now you can take it that by current division rule property. Now by current division rule, CDR, our required current I is equal to negative sign. Now minus 5 into 2 by 2 plus 1 by 3. This we got as a minus 30 by 7 amperes. This is the detailed discussion here, but you need not go for this much of discussion. Directly we are able to take it. If you know the simplification of source transformation, then definitely you will get this answer. Okay. Now let me take the next example. Got it this? Right. The question is, for the two-port networks shown in the figure, the transmission parameter A is the transmission parameters. Guys, once you recall the two-port network parameters, if you see this question, the given network is the combination of a series element and shunt element. This is the series element here and this is the shunt element. Now I can say that this is the series element and this is the shunt element. Guys, if you see that how they are connected. Now this is the network 1 and network 2, this is the series element and this is the shunt element, and this is the series element and this is the shunt element. Okay. How they are connected? Network 1 output is same as network 2 input. Then as you know that when network 1 output is same as network 2 input, both are connected in cascade. Now these two are connected. This connection is what connection? I can say that this connection is what connection? Cascade connection. This connection is called what? This is cascade connection. Once you ensure that both are connected in cascade, if you want to get that transmission parameters always allows the cascade connection multiplication. Resultant network transmission parameters or ABCD parameters, if you want to get it, that it allows multiplication of the individual transmission parameters or individual ABCD parameters. Now let us take that here, the detailed discussion for that. This is the series element, shunt element. As you know that series element, shunt element are transmission parameters. Now network 1 and network 2, let me take that the detailed solution for this. Now transmission parameters allows cascade connection multiplication. Transmission parameters allows matrix multiplication of individual networks. Individual networks parameters. What parameters? T parameters. Now, what is that first network, total network here? I can take it, total network ABCD parameters, transmission parameters is equal to T1 into T2. Where T1 is what? This is the series element here. This is a series element and this is the shunt element. Now I can take it multiplication. Now for series element, as you know that 1Z01 and shunt element is what? 1 0 1 by Z1. Now according to the given Zn Zm, according to that Zm and Zn. Now 1 Zn 0 1 1 0 1 by Zm, because impedance was given here. That's why we have to take it in terms of impedance only. If it is admittance given, I should go for Y. Now the multiplication, total network transmission parameters or ABCD parameters are what? ABCD parameters, I can take it 1 plus Zn by Zm. Now 0 plus Zn and 0 plus 1 by Zm and 0 plus 1. This is the way how you have to estimate the total network. What parameters? ABCD parameters here. By taking the total network ABCD parameters, see this, we are getting the total network ABCD parameters are, right, these are total network ABCD parameters. Now let me check it that which is the correct option according to the given. Now what it is, transmission parameters A is required here. A is required means directly you can take it this part. Under ABCD parameters, A is what? This is the A, 1 plus Zn by Zm. That's why you need not go for this entire calculation. 1 plus Zn by Zm. That is the option. Which is the correct option? 1 plus Zn by Zm. Which is the correct option? Option A is the correct one. 1 plus Zn by Zm. Which is that A parameter. A parameter is this one. A parameter is this one. All parameters need not. Okay. Now let me consider that this is the solution here for individual networks. We can take it what? Matrix multiplication for the transmission parameters. With that we need that only A parameters. We need that only A parameter value 1 plus Zn by Zm. Option A is the correct one. Let me consider that next example. Guys, this is the very good example. The question is, the switch in the circuit is closed at t equal to 0. Determine the value of di by dt at t equal to 0 plus. Now once you identify that, this will come under transient circuit analysis. Under transient circuit analysis here, see this one. Under transient circuit analysis, as per the switching action, we can decide the network will come under two types of the circuits are there na, source free circuits with the source circuits. Let me define that whether it is what type of network after t equal to 0. Right. Now, by taking that switching action at t equal to 0, it was given that the switch is going to be closed. Once you identify that after t equal to 0, the switch is going to be closed, then after closing the network, this current is required. This network is not affecting the inductor is not affecting with the 40 volt source. That means this is going to be source free network. But if you want to take that source free network, inductor should have pre-energized, nothing but what it should have initial current. Is it given initial current in that question? No, it is not given. Guys, if it is not given, we cannot say that as 0. We should identify that whether it is existing or not. The value of initial current decided by the switching action. Before t equal to 0, we should consider that the switching action and identify that energy storage element is affecting with the source or not. If you see that the switching action is before t equal to 0, it is open. Whenever it is open, is the inductor is affecting with the source? Yes, it is affecting with the source. Guys, this question also you are able to answer within 1 minute. Within 1 minute, only with one step. Think without ink. This is the way how you have to take it. First one, switching action. Second one is what? Energy storage element, inductor is there. Third point is what? Irregular classes. Usually we are discussing about this transient circuit analysis. 3 points you need to be remember. First one, switching action is provided or not? Yes. Second one, energy storage element is there or not? Because using these two only, transients will happen after switching action. Okay. Now the third thing is initial value of energy storage element is given or not. If it is given, we have to be consider, and you need not go for before t equal to 0 action. Right. Now if it is not given, definitely we need to identify how it is existing before t equal to 0. Nothing but the history of inductor is existing or not can be decided before t equal to 0. Now, before t equal to 0 here, switching action is open, inductor is affecting with the source. That's why definitely inductor is having initial value. To define that initial value, we need to consider that at t equal to 0 minus. Now, at t equal to 0 minus, that state is what state? Steady state. Under steady state, inductor acts as a short circuit. By replacing the inductor as a short circuit, we have to estimate the short circuit path current at t equal to 0 minus. That current can be considered as at t equal to 0 plus, since in an inductor current does not change instantaneously, right? Same current will carry. That's why that current is nothing but the initial current we are considering. Now, by seeing that before t equal to 0, when the switch is opened, by replacing inductor as short circuit at t equal to 0 minus, to obtain the initial current, take that 40 volt source and 4 plus 4. How much it is? 8. Now, 40 by 8, how much it is? 40 by 8 is 5 amperes. Nothing but initial current is 5 amp. Now, take after t equal to 0. After t equal to 0 here, guys, switch position is closed now. Now, at t equal to 0 plus, suppose if you want to get it that, here we can replace this inductor is what? At t equal to 0 plus open circuit. But it is initially energized, that's why open circuit with parallel current source you have to take it now. Now, by taking that open circuit with parallel current source, that value we got it as a 5 amperes, and the current is passing through this. According to this, this is the VL. Why we are defining the VL value? Since if you want to get that rate of change of current for an inductor, which is opposing the rate of change of current, using the rate of change of current, we are able to define that voltage across inductor according to the Faraday's law of electromagnetic induction. Now, according to the current direction, this. Now, once you apply the KVL for this one, this at t equal to 0 plus, this is open circuit. Now, how much current is passing through that in the 4 ohms resistor? It is 5 amperes. But this short circuit, guys, you may get a doubt. This short circuit is existing 2 currents, because that short circuit is affecting with the 2 circuits. One is the source circuit, other is the source free circuit. But in the source circuit, there is no energy storage element. That's why I can say that here, the KVL, if you take it here, this is V4 ohms and VL of 0 plus is equal to 0. With this, direct I can take it, VL of 0 plus value, how much you can take it? VL of 0 plus V4 is equal to 0. This is the step you have to take it here directly. Now, from this, VL of 0 plus is equal to minus V4. Minus V4 means what? How much current is passing through this? 5 amperes now. At t equal to 0 plus. Now, minus 4 into 5, how much you are getting that? Minus 20. Minus 20, this VL of 0 plus, how can I write, guys? Now, I can replace that VL of 0 plus as, what it is? L into dIL of 0 plus by dt. That is di of 0 plus by dt is equal to minus 20 here. Finally, what we are getting, that di of 0 plus by dt is equal to, these are the only steps you can take it. L value, how much it is given? 2 henries. Now, from that, minus 2 by 2, which is equal to minus 10 amperes per second. Now, which is the correct option? Minus 10 amperes per second. We have to be consider which option? A is the correct one. This is the way how you have to perform in the examination. But some of you, you may not have the detailed discussion, you may not have directly, you may not get that concept of this one. For them, I can take the detailed solution for this, right? Detailed solution means I can take it the detailed solution here. In the next page, solution for this one, detailed solution. In the detailed solution, guys, you have to be consider, because this is source free circuit, for t less than 0 and for t greater than 0, this is t equal to 0 minus condition, this is t equal to 0 plus condition, both are within 0 time, you know that. Okay. Now for t less than 0, switch position is what? Switch is open. Once the switch is opened, is the inductor is affecting with the source? Yes, 40 volt source it is affecting. Then on the time at t equal to 0 minus, this state is nothing but what? Steady state. Under steady state, how the inductor act as? Inductor act as short circuit. Right? Now replace that. Now this is the step number 1 I will consider. Under step number 1, getting guys? Under step number 1, for t less than 0, inductor is affecting at t equal to, because of this one only I am going to add this. Suppose inductor is not affecting, initial value is equal to 0. Now at t equal to 0 minus, which is under steady state, inductor act as short circuit. By taking that inductor act as short circuit, how the network? Let me take that network how it is. Switch is open. This is the circuit, you can take it. Here 40 volts, here 4 ohms, here 4 ohms. This is IL of 0 minus. Getting guys? Now IL of 0 minus 40 by 4 plus 4, which is equal to 5 amperes, is same as IL of 0 plus. Since current does not change instantaneously, that means within 0 time, this current is called initial current. Are you getting guys? This current is called initial current. Detailed discussion here. Now once you obtain that initial current, then definitely we should go for what? We need to take at t equal to 0 plus condition. Let me consider that at t equal to 0 plus condition. Now at t equal to second step number 2. At t equal to 0 plus, switch is closed here. Once the switch is closed, inductor is not affecting with the source. L is not affecting. If L is not affecting, but it is having initial current, that's why it is called RL source free circuit. CKT means RL source free, CKT means circuit here. Now let me take that how the network. See that network. Now this is, I can take it, this is for t greater than 0. After that we will go for the at t equal to 0 plus also. For detailed discussion here. This is 2 Henry. With is having this direction, I naught is equal to 5 amperes. Now he was given this is I, and this is 4 ohms, and this is 4 ohms. You may get a doubt here. This inductor, why not it is affecting? The current is dividing. No, current will not divide. The short circuit path, it allows always entire current, total current which is coming from the all the other circuits. Nothing but what these two circuits are. Remember that these two circuits are individually physically connected, but electrically they are not connected. Short circuit is connected electrically. This short circuit is connected electrically. Whatever the current is coming here, the resultant current of the short circuit path is here. What it is? The opposing, nothing but what difference between these two currents are existing. Nothing but you can say these two are connected physically but not electrically. These two circuits are connected physically but not electrically, because this current is not affecting with this current is not affecting with this. That's why I can say that both are not connected electrically. That's why this will come under source free circuit. This will come under source free circuit. Are you getting guys? Now we have to be consider this one. Sir, you may get a doubt here, why you are not considering about this, but we don't need that question is given di of d by dt, which is related with the source free circuit. That's why we have to be considered under source free circuit. Now let me take that at t equal to 0 plus. Step number 3. At t equal to 0 plus, switch is closed, no doubt in that. Inductor act as what? Inductor act as open circuit with series current source, a parallel current source. Resistor act as a resistor only here. There is no change in the resistor behavior. Now, I will consider that, let me take it, I will consider that only the source free circuit. Why we are doing this exercise? Since we have to estimate that rate of change of current. If you want to get the rate of change of current, for source free circuit definitely rate of change of current is opposing, because what it is, voltage polarity should be reversed for source free circuit. Remember that. Now I can take it here, this how much current? 5 amperes, positive to negative. Now here 5 amperes. Now from this I can take it by KVL. What I can take it by KVL, VL of 0 plus V4 ohms is equal to 0. Now VL of 0 plus is what? di of 0 plus by dt. Since the current is given, now I value how much? 5 into 4 is equal to 0. Now what I can take it here? di of 0 plus by dt. Now from this di of 0 plus by dt is equal to minus 20 by L minus 20 by 2, which is minus 10 amperes per second. Finally, what I can take it here? I will consider that as per the question, di by dt is equal to minus 10 amperes per second. Got it? Now, which is the correct option according to the given options? Right, got it this? This is the step number 3. From this, we are going to get that our required value. What it is? Minus 10 amperes per second directly we are getting. But in the examination, guys, you have to follow whatever the discussion we made by using only this circuit, this equation. Directly we are able to take it. Rest of the things you should get it directly, or you need to get it without taking any calculations. Right? You have to think how it is existing, the circuit at t equal to 0 plus, including the initial current if it is existing, right? Then only you are able to take, or you can imagine the network at t equal to 0 plus, then you are able to write the KVL expression, okay? Right. Now, let me take the next example. Right. The time constant for the below circuit is, guys, this is also related with what? Transient circuit analysis. Time constant. Time constant can be defined if you take that any network first by deciding the given network is, whether it is the first order network or the second order network. For the second order network, we should go for whether it is overdamped, underdamped and critically damped, that you can easily identify whether the network is first order or second order based on the number of energy storage elements are present. Once you see that is it first order or second order, here the energy storage elements, how many are there? Only one is there, that is the capacitor. That's why I can say that this is the first order network. You are having that information regarding the first order circuits. It can be either RL circuit or RC circuit. For an RL circuit and RC circuit, the time constant, if it is RL circuit, L by R, if it is multiple resistors, inductors are connected or present in the network, L equivalent by R equivalent, or RC network is there, if it is first order, the time constant tau is equal to R equivalent into C equivalent if multiples, or single elements are present R into C. Now, once you ensure this is the first order, then we should go for that whether RL or RC. Definitely I can say that it is RC. For RC network, the time constant of first order is equal to R into C. But here multiple resistors are present. Once the multiple resistors are present for the first order, you need to go for that the separable point. Once you know that separable point, then I am able to define that R equivalent. Right. Now only one capacitor is there. See this guys, only one capacitor is there. This is only one capacitor is there. Now for directly I am writing that definitely calculation is required for this one. Time constant of first order RC circuit, time constant tau for first order RC circuit. You know guys, here tau is equal to R into C, or R equivalent into C, or R equivalent into C equivalent seconds. Now to define that R equivalent, definitely I should see from this separable point, this is C equivalent or this is R equivalent. Only one capacitor is there, directly I can take the C value is equal to 0.25 millifarad. But while coming to that R equivalent, sources are present. You know that whenever the independent sources are there, they should be deactivated. How you deactivate the independent sources? By making their internal resistance at ideal condition, nothing but voltage source as short circuit and current source as open circuit. Guys, you can easily identify that current source, this is open circuit series parallel, series element, passive element can be neglected. But while coming to that voltage source is short circuit, then this is 2 ohms both are in series, 4 are in parallel, 2 in series with what? 23, nothing but 25 is the R equivalent. According to that you can get it. Now let me take that the solution for R equivalent. For R equivalent, see this, for R equivalent, make the voltage source as a short circuit, independent, current source as open circuit. Now by taking that voltage source as short circuit and current source as open circuit, I am able to take this network as like this. See this one? You need to look from these two terminals here. By looking into these two terminals, you can get it. You should look from here. Separable point. From the separable point. These are the separable points, I can take it here. By looking into this, now this one is 1 milliohm is given, and this is the open circuit and this is the short circuit. This is 2 ohms and 2 ohms and 4 ohms and 23 ohms. Okay. See this guys, how we have developed the network for R equivalent. For R equivalent, now you can see that this can be neglected. Is it right? This can be neglected. Once you neglect this, once you neglect that, these two are connected in series, okay, and both are in parallel. Now R equivalent value I can write directly. R equivalent is equal to 2 plus 2 parallel with 4 and total in series with 23, which is equal to what? 4 and 4 parallel, how much? 4 and 4 parallel is 2 with this 2 plus 23, which is equal to 25 ohms. Getting? Now once you obtain that here, R equivalent and C, then we can go for the time constant. Time constant tau is equal to R equivalent into C. Now R equivalent value 25 ohms, we got it, and this is 0.25 na? 0.25 millifarads. Milli means 10 power minus 3. Now this is 25 into 25, 625, but after 2 here 625, 6.25 milli, as it is here you are getting that into 10 power minus 3 seconds. Now tau value is equal to 6.25 milliseconds, okay. Okay. Now let me take that here, which is the correct option. As per the given options, I can say that, right, 6.25 milliseconds. Option A is the correct one here. Option A is the correct one. A is the correct one. Are you getting that? Now, the entire solution, only the calculation of what? R equivalent. Here, you have to concentrate more on equivalent resistance. By neglecting, by deactivating the independent sources, you can easily get it. Okay. Now, let me take the next example. Right. For the circuit shown below, determine the value of the damping ratio here. Guys, this is related with that damping ratio means AC circuit analysis. Under AC circuit analysis, you are aware of that this is the standard network which is RLC series network. If you want to get it the damping ratio, by knowing the RLC values, you are having the direct formula here. What is the direct formula? 2 by R into under root C by L. That is the damping ratio or damping factor. But if you are not able to memorize that formula, we have that relation between the damping factor and quality factor for any type of network. Can be any standard series and parallel network. We have the general relation between the damping factor and quality factor. Damping ratio, damping factor is equal to 1 by 2 times of the Q factor. That is, using that you can get it. Now, the solution here, damping factor or damping ratio is equal to damping ratio of series RLC series or parallel circuit, RLC series or parallel circuit. This you have to take it here. Direct formula, if you know that, then you can go for that, or otherwise zeta is equal to 1 by 2q. This is important here. From this, I am able to take that. Okay. Now, quality factor of series, quality factor of parallel, you know that. By knowing that, I can take it. See this. Quality factor, Q factor of series network is equal to what it is? 1 by R times of under root L by C. Actually, this one is omega naught L by R here, or omega naught 1 by omega naught CR. Now, omega naught is equal to 1 by root LC. Then on the time you are getting that under root L by C, 1 by R times of, because in terms of he was given that R LC values. Now, from this the quality factor for this one, the damping factor, damping ratio is equal to zeta 1 by 2q, where q is equal to what? 1 by R times of 1 by R times of under root L by C. Now, from this zeta damping ratio is equal to R by 2 times of under root C by L. Now, here it is very simple, just you have to substitute the values, given values, 5 ohms, 1 millihenry, 10 microfarads, right. 5 ohms, 1 millihenry, 10 microfarads. Now, from these 2.5 into 10 milli, 10 micro, 10 power minus 6 and 1 milli, 10 power minus 3. What you are getting, guys? 10 power 5, you will get 10 power minus 2 because minus 3 is there. Now, 10 power minus 2, if you take outside, then what we are getting that? This is 0.25. Damping ratio is equal to zeta is equal to 0.25. No units for this one. 0.25. This is the answer for this one. Let me take that. Have you got that? How you have to remember? For parallel circuit, suppose if you are considering that QP is equal to what? R times of reverse. Once if it is reverse, then on the time this one also reverse. QP you will get it parallel circuit. Then you will reverse, you will get it. R times of under root C by L. Right? Based on that you can take it. Here series circuit is given. That's why 0.25 we got it. Which is the correct one? The correct one is A is the correct one. A is the correct one. Have you got it? It's a very simple here. Very simple question. Let me take the next example. Okay. Right, good example. The voltage across the last resistor V is given. All the resistors are unity. Then Vs is given. Guys, directly we are able to take it without putting pen here also. I will give that how you have to be considered. See this one directly. Later I will discuss detailing. Now see this one. This is the last one. Now here 1 volt, here V is there. V means what? You can take it, V means how much you are getting that? V by 1, V amperes. If V amperes you are getting that, how much voltage here? V volts you are getting. If V and V, how much you are getting here? 2V you are getting. How much current here? 2V1, 2V. Here 2V, V. How much current here? 3V. 3V into 1, 3V volts. Now 3V plus 2V, how much it is? 5V. With the 5V, how much current? 5V by 1. How much the total current here? By KCL, what we are getting that here? 8V. Now once how much current is passing? 8V. How much voltage drop across this? 8V volts or 8 volts. Now from this what we are getting? 8V plus 5V. How much Vs? We can add it both. 8 plus 5. 8V plus 5V. How much it is? 13V volts. It's a very simple here. KVL, KCL first, KVL. Next KCL, KVL. KCL, KVL. Only simple basics here we are considering. Are you getting that? Now let me take that one by one. Once again I will explain here. Once again I will explain how we are getting. First one is V volts given here. V by 1 amperes, V amperes. V into 1, V volts. By KVL, go for KVL. Guys, go for KVL. Positive, positive. Nothing but V plus V, 2V. Now by knowing the voltage, you can get the current by using the resistance. 2V by 1, 2V amperes. Now by KCL here. By KCL, 2V, V. 3V. 3V current is passing through that. By knowing the current and resistance, voltage, 3V volts. 3V plus, again you need to go for what? KVL for this one. 3V plus 2V. How much it is? 5V. Now here once you get the 5V, 5V by 1, how much it is? 5V amperes. Now again KCL here. Simply here KVL, KCL only here we are considering KCL. 3V amperes, 5V amperes, 8V amperes. 8V amperes current is passing through the 1 ohm. 8V volts. Now again we should go for the KVL. 8V plus 5V, 13V. That's why by KCL, KVL, you are getting that here by using KVL and KCL. Are you getting, guys? It's a very simple question here under basics. This is under basic terminology. By using KVL and KCL, Vs is equal to, what it is? Vs is equal to 13V. Getting? Which is the correct option? The correct option is A. A is the correct option. Are you getting? KVL, KCL. KVL, KCL. KVL. Based on that, we can get it. See this one, guys. If you are not able to get it, I am zooming this entire thing. KCL, current, same current, both are in series. KCL and KVL. KCL, KVL. Only KVL, KCL. You are getting this answer. Okay? Okay? These are the questions under mock test 1 with the subject of network theory. Right? All the best.
Subject is control systems. Now here in this one, the first question is about the sensitivity. Sensitivity means trans function is given. Now examiner is asking SKT of the system is. What is the formula for SKT? Sensitivity formula. The given trans function is this one. When the given trans function is like this, what is the SKT formula here? SKT formula. This is the overall trans function T. That formula equal to dou T by T upon dou K upon K dl. This is nothing but, let us, this is a trans function T equal to equation number 1. Now we can write K upon T, dou upon dou K upon T. T means in the place of T you can substitute this K by K upon S square plus 2S plus K, guys. Now dear students, here observe SKT equal to K upon, in the place of T, write this one K upon means it will go to the numerator S square plus 2S plus K. Now in this bracket, U by V formula with respect to K, na? So denominator part S square plus 2S plus K, differentiation of K 1 minus U by V formula K, differentiation of this term. With respect to K means S square 0, 2S 0, okay, K means 1 only. Upon denominator part square only. Denominator part square S square plus 2S plus K whole square here. Now cancel numerator term here, denominator term. We can cancel this term, this 1 square plus K minus K also cancel. After this one, what is the answer we are getting? Answer will get here SKT equal to this K also cancel. S square plus 2S only. We can take the common, S plus 2 in the numerator upon S square plus 2S plus K, guys. Hello dear students. Now this is the examiner is asking sensitivity with respect to K for the overall trans function. What is the best suitable answer? No doubt option C is correct answer. Option C is right answer for this question. BARC mock test 1 control system question subject. Now we'll go for the second question here. Second question. Now for the given data, once read the given data. What the examiner is asking? What is the given data first of all? The trans function of a unity feedback system type 1 here. Type 1 means so denominator part 1 by S should be there. Type 1 means 1 by S should be there. This is a type 1 here. Type 1. That is the meaning of type 1. And second order. Second order means there are 2 S term in the denominator. One more pole where it is given S equal to minus 2 is one pole is given. So I am writing roughly trans function equal to forward path. No, I am writing G of S equal to, because of type 1 S power 1 and one more pole is S plus S equal to minus 2 means S plus 2. This is given. This is a given data. And unity feedback system H of S equal to 1, guys. Yes, very good. Now K is adjusted such that damping ratio zeta is given how much here? Given zeta equal to damping ratio 0.4 here. 0.4 means 4 by 10, that is nothing but 2 upon 5 we can write. This is a given data first of all. And steady state error is asking. First we will go to the what is the G of S equal to next page. G of S equal to given trans function 1 by S product of S square plus 2S H of S equal to 1. What is the characteristic equation here? Characteristic equation equal to 1 plus G of S H of S. 1 plus G of S H of S. Now substitute here. So we will get S square. Sorry. Now system gain K is given. So we don't know what is the value of K. So K. This is also K here. This is a K here. System gain K. So S square plus 2S plus K equal to 0, guys. What is the standard second order system closed loop trans function? Now standard characteristic equation. Tell me standard characteristic equation. Allow standard characteristic S square plus 2 zeta omega ns plus omega n square equal to 0. From this 2, what is the K equal to? K equal to omega n square. K equal to omega n square, equation number 1 here. First, K equal to omega n square. If you compare this one, now 2 zeta omega n except S, 2 zeta omega n equal to 2. 2 zeta equal to how much previous, okay, given, how much is given? 2 by 5. 2 by 5 product of omega n equal to 2. This side 2 to cancel. So what is the omega n value equal to? Omega n value equal to 5 by 2. Substitute in equation number 1. So what is the K equal to? Substitute in equation number 1. Substitute in equation number 1. So K equal to how much will get? K equal how much we will get, come on help me, K equal to omega n square. Omega n square means 5 by 2 whole square. So 25 by 4. This is a K value. So we got the K value. So overall trans function equal to what? Overall this open loop trans function equal now G of S equal to K equal to we got 25 by 4. 25 by 4 upon product of S into S plus 2. S into S plus 2. This is a trans function. H of S equal to 1 only. H of S equal to 1 only. Given data. Unity feedback system. Now here one more thing. What is the examiner is asking? Steady state error. Na? Steady state error means this is a unity step. This is a T power means ramp signal. So what we can write here? This is a now I am writing this is a unit step here. Unit step here. This is a unit step. Where about second one is a ramp signal. Ramp signal. So both I am calling as a first one is a ESS1. Steady state error 1 here. Steady state error 1 plus steady state error 2 due to ramp signal. This thing we need to find here. This thing we need to find here. So total steady state error equal to ESS equal to ESS1 plus ESS2. First I am finding ESS1. So steady state error 1 here. Now error SSC for unit step input. For unit step input. What is the steady state error? ESS equal to 1 by 1 plus Kp. Why unit step is given clearly 1 only, unit step only, but it is not a unit ramp, 4 is given. What is the Kp equal to? Kp equal to, tell me, position error constant. Na? Kp equal to limit S tends to 0, G of S product of H of S, this is a formula. So here help me guys. Hello dear students. Now G of S 25 by 4 S product of S plus 2. Wherever S is there, substitute S equal to 0 here. Substitute S equal to 0. Something by 0. What is the something by 0? What is the answer? Come on, tell me. Infinity. Something by 0 infinity. Substitute in the ESS1. So steady state error 1 here. Steady state error 1 equal to 1 by 1 plus infinity. So answer is 0. First one. Steady state error 1 equal to. Now okay, fine. Steady state error 1. Next steady state error for ramp input. For ramp input ESS2 equal to, it is not unit ramp, formula A by kV. A means amplitude. Why? Because either observe amplitude is given 4 only. Here amplitude is given 4 only. So because of T product, okay, here A equal to given 4. And what is the kV equal to? Velocity error constant. kV equal to velocity error constant, limit S tends to 0. S product of G of S, H of S. Now substitute limit S tends to 0. S product of G of S, H of S. G of S, H of S equal to. G of S equal to K by G of S 20 by 4. Now 20 by 4 upon S into S plus 2. S product of S plus 2 here. Now after cancellation here, observe anyone, SS cancel, S tends to 0. So something by, so what is the answer? Will get 20 by 5, 4 into 2, 8 here, 8. But ESS2 equal to A by KV, na, A equal to 4 by KV, 25 by 5. Now, okay, fine. A by KV, na, 20 by 5, 4. Yeah, nice. A equal to 4. Now, this is nothing but 25 by 8 here. So, answer will get 4 into 8, 32 by 25. 32 by 25, this is approximately 1.28 here. 1.28 here. So, what is the total steady state error equal to? Total steady state error ESS equal to ESS1 due to unit step plus due to ramp signal. Due to unit step signal, go to the previous page, ESS1 equal to 0, 0 plus this ESS2 equal to 1.28. So, answer is 1.28 dears. Answer is 1.28. So what is the given option here? No doubt option A is correct answer. Option A is correct answer, dear. So right answer is option A. Option A is right answer for the given data. Once again read the question. This question was given, okay, BARC mark test 1 control system subject. Similarly, we will move to the third question. It is time for the third question. One more question from in the control system. Yes. Now, from the Routh-Hurwitz method, this question was given. Oscillation is given. Means frequency of oscillation is given. Examiner was given. Here, what is the given? Frequency of oscillation is given. Frequency of oscillation is given. That is omega equal to square root of 2. Sorry, 2 only. Not square root of 2. 2 only. 2 radian per second is given. But frequency of oscillation is calculated only for marginal stable system only. Marginal stable system only. First, what is the given data here? Given data. This we can write Ks plus Ka upon S product of multiply S square plus 2S plus 1, 3S plus 2, guys. This is nothing but Ks plus Ka upon multiply S power 3, 3S square plus 2S. What is the characteristic equation equal to? Now help me, characteristic equation equal to 1 plus G of S H of S. So if you 1 plus G of S H of S formula, S power 3 plus 3S square. Take the S common, in numerator S, denominator S. So K plus 2 product of S, constant term, plus K into A equal to 0. But one beautiful shortcut technique, if characteristic equation equal to shortcut technique, S power 3 AS square plus BS plus K equal to 0, then frequency of oscillation or intersection point with imaginary axis, root locus, both shortcut is same only, square root of B only, dear. This S power 1 is then square root of B only. Regular method means take the Routh-Hurwitz method, one complete row is 0, write the auxiliary equation, then it takes a lot of time. Better, given frequency of oscillation, so frequency of oscillation is given. Frequency of oscillation is nothing but S power 1 term square root of K plus 2. But in the question paper is given what? Frequency of oscillation is given 2. 2 square on both sides. So K plus 2 equal to 4. So no doubt K equal to 4 minus 2, 2 only, guys. Now the perfect answer K equal to 2 is correct answer. K equal to 2 is correct answer. So here in the given options, check it. So K equal to 2 is right answer. K equal to 2 is right answer, dear. Option A is right answer. So this is a question. Now one more question here. Yes, very good question. Root locus, same formula. Once observe. Here I am writing there are 3 poles is given. One pole is here, one pole is here. Now I am writing once again, one pole is here. Once again I am writing. At minus 4 there is a one pole is given. Again at examiner was given where at minus 1 plus 1j minus 1j one more pole is given. From the root locus diagram, what is the given here? Given poles are at S equal to minus 4, given from root locus diagram, given poles are at tell me at S equal to minus 4, at S equal to minus 1 plus 1j, again minus 1 minus 1j. There are 3 poles here. Minus 1 minus 1j. Now minus 1 minus 1j, these are the poles, guys. So examiner is asking where it is this root locus point, where it is intersecting, this point is asking. This point is asking, at this particular point is asking here, where the root locus point is intersecting. This particular point is asking, this is a question mark. That is a question mark. Imaginary axis. Same only, frequency of oscillation shortcut only. So first of all, we have to write the characteristic question. What are the poles here? Trans function equal to G of S equal to trans function equal to something K by S equal to 4 means S plus 4. This is a S plus minus 1j s plus 1j. This two a plus b into a product of b. A plus b, a minus b, a plus b, a minus b. What is the answer we can write? That is nothing but g of s equal to k upon s plus 4. Now tell me a plus b into that, if you expand 2s plus 2 guys. Now again multiply this one, k upon s power 3, 2s square plus 4s square, 6s square plus 2s plus 8s, 10s, 2 into 4, 8 here, 8. So what is the characteristic equation equal to? Characteristic equation equal to 1 plus g of s h of s. Characteristic equation equal to 1 plus g of s h of s. That answer will get 8s square plus 10s, 10s plus 8 plus k here, 8 plus k equal to 0. The shortcut here, whether frequency of oscillation or intersection point with imaginary axis. Intersection point root locus diagram, root locus intersection point with imaginary axis, imaginary, or frequency of oscillation shortcut here, square root of b only here. If characteristic equation is like this, shortcut. If characteristic equation s power 3 as square plus bs plus something k equal to 0, then this is a technique here. A regular method means to form the Raut-Hurwitz method, one complete row 0, find the k marginal, write the auxiliary equation, then that is a difficult method. Here square s power 1 coefficient here. So intersection point with imaginary axis. IP means intersection point with imaginary equal to square root of 2. Imaginary means you have to get the plus or minus j term here. Plus or minus j term square root of 2. So plus or minus j, this is a 3.16 something. Square root of 10, 3.16. So 3.16 here. No doubt option A is correct answer. So we can write this option A is right answer here. Where it is intersecting means 3.16j and minus 3.16j here. This is a root locus diagram question. Now once observe the solution also. Wow, very good. Yes, one more data, direct question. This is actual direct question. Direct standard from Nagarat and Gopal, direct bit here. It is a direct bit. But I am going to solve here, derivation. I am going to derive here. Phase crossover frequency, gain crossover, okay, gain margin here. First thing, my dear friends, first thing, what is the gain margin formula? Tell me, anyone? Gain margin, tell me. Gain margin equal to reciprocal of the magnitude, guys. Reciprocal of the magnitude, where it is asking at omega equal to omega pc. At omega equal to omega pc, phase crossover frequency, equation number 1. So it is our duty to first to find the phase crossover frequency. So first find phase crossover frequency omega pc. How to find the phase crossover frequency here? Phase crossover frequency formula, phase crossover frequency formula here. Now the formula for phase crossover frequency formula, phase angle at omega equal to omega pc must be equal to minus 180 degrees. So apply the phase angle for this one. Apply the phase angle for this one. Phase angle for this one. Apply the phase angle at omega equal to omega pc. At omega equal to omega pc. At omega equal to omega pc, this value should be minus 180 degrees. Phase angle of k is 0 degrees. So phase angle of k equal to 0 degrees. Phase angle of s minus 90 degrees. Phase angle of denominator means minus tan inverse of omega t1. S equal to j omega t1 by real part by imaginary part by real part. Omega t by 1 minus tan inverse of omega t2 by 1 equal to minus 180 degrees. Minus cancel, 90 also that side. So overall we are getting tan inverse of omega t1 plus tan inverse of omega t2 equal to 90 degrees. Tan inverse of a plus b. Now help me anyone, tan inverse of a plus b. Tan inverse of omega t1 plus omega t2 upon 1 minus omega t1 into omega t2. Omega square t1 product of t2 equal to 90 degrees. Now tell me anyone, tan that side means infinity. Na? Tan that side means now. So what is the value we are getting? Come on, help me. omega t1 plus omega t2 upon 1 minus omega square t1 t2 tan 90 infinity. Infinity means we can write 1 by 0. Cross multiply, if we cross multiply, so if we, okay, 0 into 1, so what we can write 1 minus omega square t1 t2. So omega is nothing but omega pc only. Omega pc equal to square 1 by square root of t1 t2 guys. T1 t2. This is a phase crossover frequency. One check it, phase crossover frequency. Phase crossover frequency equal to 1 by square root of t1 t2. Now observe the options here. Observe the option. Second one is a phase crossover. First one is gain margin. Second one is a phase crossover frequency. Second one, T1 plus T2 wrong option. T1 T2 may be in the option, may be in the option. So both are eliminated guys here. Both are eliminated. A and D are eliminated. Next we need to find the gain margin here. To find the gain margin, it is our duty reciprocal of the magnitude. First we will find the magnitude here. First we will find the magnitude here. How to find the magnitude here? Now it's time for the magnitude. But magnitude where at omega equal to omega pc equal to 1 by square root of t1 t2 guys. Magnitude, please help me. Magnitude equal to is the magnitude. Now what is the trans function equal to k by s into 1 plus st1, s equal to j omega t1, 1 plus s j omega t1 product of 1 plus s j omega t2. Now this is a magnitude we are finding. After finding magnitude, find the reciprocal here. So examiner is asking where, tell me, at omega equal to omega pc equal to 1 by square root of t1 t2 is asking to find. Actually direct it is a magnitude. Now tell me here k by omega j, s equal to magnitude j omega mod j is 1, omega equal to omega pc, omega equal to omega pc, 1 by s means 1 by square root of t1 t2. Next to square root of 1 square plus omega pc square plus t1 square. Next to 1 square omega pc square plus t2 square. Wherever the omega pc is there, substitute the omega pc value. Now I am substituting the omega pc value k by this 1 by, so I am writing in the numerator t1 t2 square root of, please help me, square root of 1 plus omega pc square, omega pc 1 by t1, so 1 by t1 t2 product of t1 square, again square root of 1 plus omega pc square, omega pc is this one, square root means 1 by t1 t2 then t2 square. Finally what happens, tell me, hello guys, tell me. T1 square, this square T1 cancel, T2 square T2 cancel here. So now tell me here, this value I am writing magnitude only at omega equal to omega pc only. What is the value I am writing? K square root of T1 T2, K square root of T1 T2 upon, it is standard. Now 1 plus T1 by T2 square root of 1 plus T1 by T2. So after taking LCM, T1 plus T2 by T1, T2 square root of, next one also take the LCM, T1 plus T2 upon T1 here. So what happens here, later this T2, T1 in the square root only, that is also comes under, this is nothing but K square root of T1 T2 square root of T1 plus 2 square root of T1 plus T2. How to write here? Only T1 plus T2. This denominator we can write square root of T1 into T2. If we come front side, K T1 T2 only simple T1 T2 upon T1 plus T2. But shocking, examiner is not asking the magnitude, gain margin is asking. But gain margin is what? Come on, tell me from the equation number 1. Once go back to the equation number 1. Reciprocal of the magnitude. Reciprocal of the magnitude. So gain margin is a reciprocal of the magnitude. A reciprocal of the magnitude at omega equal to omega PC, guys. Now, reciprocal of this one means what happens? Up become down, down become up. Numerator become denominator, denominator become numerator. So this is a gain margin formula. This is a gain margin standard. No need to derive in the exam hall. You have to remember. As a faculty, I have derived. So what is the best suitable answer here? Already we rejected 2 options here. Now K T1 plus T2 by option C is correct answer, guys. Option C is right answer. Option C is right answer here. This is the gain margin and phase margin from the Bode plot. Standard equation. Type 1 order 3 questions. Phase crossover and gain margin. We will go for the one more question. Yes, lead compensator. Actually, there are different textbooks are using different formula. Different formulas are using means the transfunction assumption also different. I will follow the simple formula here. What is the lead compensator? It must be having transfunction of the lead compensator. Something K present in the numerator. Numerator means 0. Pole at -4, 0 A to -2. So 0 at -2. Pole at where? Come on, S plus 4, guys. S plus 4. What is the standard transfunction of the lead compensator? Standard something K into S plus 1 by T upon S plus 1 by alpha T. Some textbooks will take different format here, standard. But if you take like this, the formulas will change. What is the 1 by T equal? 1 by T equal 2. So after comparison, 1 by T equal 2 here. So T equal how much, sir? 1 by 2, that is a 1 by 2 here. 1 by 2 is equal to 0.5. This is a time constant, we got it. Time constant, we got it. Similarly, from here, what we can write? 1 by alpha T equal to 4. 1 by alpha T equal to 4. 1 by alpha T equal to 4. So tell me alpha T equal to 1 by 4. Alpha equal to 4 into T. 4 into T. T equal to 1 by 2. So now T equal to what? Come on, tell me. 4 into 1 by 4 into T. T equal to how much? Come on, tell me. 4. Again 1 by 2. 1 by 2 means what? Come on, 1 by 2 only. So alpha equal to also 1 by 2 here. Alpha equal also 1 by 2. Keep this one also equation number. Different. Okay. Now is asking omega m here. Examiner is asking omega m frequency, that is the 1 by T square root of alpha. 1 by T square root of alpha. 1 by T. What is the T equal to? 1 by T. 1 by T means 1 by 2 square root of alpha. Again 1 by 2. So that is nothing but 2 square root of 2. 2 inside means 4. 4 into 2 means 8 only. So omega m is square root of 8 radian per second here. Omega m equals square root of 8 radian per second in the given option. Omega m here, square root of 8. Square root of 8 means what are the option? You can eliminate square root of 2, wrong option. Square root of 2 is wrong option. Option D, option A are wrong options. Still 2 are in the race here. Still 2 are in the race. Again, the formula pi m, maximum phase angle, is asking sin inverse of 1 minus alpha by 1 plus alpha. Students, be careful. This formula, different textbook are using different. Alpha minus 1 by alpha plus 1. But when that formula is suitable, here, these standard transfunction they will assume differently. Based upon the standard. Better take this one for this standard transfunction. This is a formula, guys. So 1 minus alpha equal to sin inverse of 1 minus alpha equal to 1 by 2 upon 1 plus 1 by 2. So this answer you will get sin inverse of 1 by 3 here. 1 by 3 means 19 point something 4 here. 47. That is approximately near to the equal to 20 degrees here. Keep the calculator in the degrees mode. If the calculator is allowed, then only they are going to ask this type of questions. But sin inverse of, okay, near to the 20 degrees. 20 degrees means obviously option C is correct answer. Option C is correct answer, guys. These are from the compensator and controllers here. Compensator controllers. Now read the question. Now assume this is a standard transfunction. These are standard transfunction. Now, okay, fine, happy. This is about the compensator questions. Next to one more question. Yeah, it is a standard, no doubt. Root locus diagram related. There are two poles here. What the examiner is asking? This type of question, direct this is a question. I will explain. If you take the root locus diagram here, there are two poles here. Why? Because B greater than A. There are two poles here. S equal to 0, S equal to minus 1, and one 0 at minus B. This is at origin, this is at minus A. It is S equal to minus A, S equal to minus A, S equal to 0. This is S equal to minus B. Examiner is asking B greater than A. Na? Okay, now, if you draw the root locus diagram, pole must reach as the 0. We need to assume there exists a 0 at S equal to infinity, guys. Assumed 0, S equal to minus infinity, there is a assumed 0 will exist. What will be the root locus? Every pole must reach the 0. Every pole must reach the 0. This is the root locus diagram. Just I am giving explanation, but not a direct question. Is root locus moving means so this pole will move like this pole will move after reaching this 0. So wherever this point here, this is called as a, this point is called as they are away from the axis, this is called as a breakaway point. This is called as a break-in point, guys, break-in point here. So examiner is asking radius. Radius means so this two difference here. This two difference is the diameter. Diameter and diameter of is the radius. Diameter of is the radius. So what is what we can write? Break-in point minus breakaway point by 2 for what we can call radius. But standard, if you find, no doubt option A is correct answer, guys. This is standard equation. If you want now, sir, means to find the breakaway point, find the break-in point minus breakaway point by 2. Why? Because this two difference is called as the diameter of is called as the radius here. Always in the question paper, this 0 location is called as a center, minus B 0. S equal to, S plus B equal to 0, S equal to minus B. So this is standard equation, B square minus AB. If you want regular method, this is a break-in point minus breakaway point by 2. After finding radius, so okay, fine, good. Let us, this is about the root locus diagram. Now one more question. The time response of the standard second order system to a unit step input is shown in figure. I will draw the figure. The first peak is 5 times of the first overshoot, then the damping ratio of the system is. I will draw the diagram. What is the examiner here is asking? This is a standard diagram. Unit step input examiner is given. Unit step input standard diagram is given. Now, okay, this is called as a, let us, this difference is called as MP, guys, MP, M suffix P. And from year to year, this is called as a TP. Now, please help me, TP equal what we can write, Pico, okay, peak time equal to this 1 plus MP. 1 plus MP, correct na? 1 plus MP. That we can write. And also is given, first peak is a 5 times of the first overshoot. Again given TP equal to 5 times of MP. These two are given. First peak is a 5 times of the first peak overshoot. TP is 5 MP. Again TP equal to 1 plus MP. Both from both equation what we can write? 1 plus MP equal to, okay, 1 plus MP equal to what we can write? 5 MP. So MP this side, 4 MP equal to what? Tell me. 4 MP equal to 1. MP peak overshoot equal to 1 by 4, guys. 1 by 4, that is a 0.25. We have the formula of MP. What is the MP formula? Anyone tell me? MP formula equal to e to the power of minus zeta pi upon square root of 1 minus zeta square. But when we given zeta to find the MP, here reverse, MP is given, we need to find the zeta. This is a regular formula, but this is a rare formula. Zeta equal to square root of natural logarithm ln MP square upon ln MP square plus pi square. This is a thing, very rare formula, but regularly you will observe this formula in engineering college. Substitute MP value, so no doubt zeta approximately you will get 0.4 here. If you substitute, you will get the 0.4, guys. So no doubt option C is right answer. Option C is right answer, guys. Now, option C is correct answer. This is a give from the given data we calculated. Now one more question in the mark test 1 BARC electrical people. This is a control system. Last question. There are two systems are given, cascaded is asking. When two systems are given cascaded, hello guys, when two systems are given cascaded here, when two systems are given, first G1, second G2, then overall system is from the block diagram, G1, G2 guys, both. The two systems are cascaded in the series. Cascaded means series, G1, G2 means overall transfunction is G1 product of G2. G1 product of G2. So first transfunction here, first transfunction G1 of S equal to C1 of S by R1 of S. C1 of S by R1 of S. What is the C1 of T is given? C1 of T, where is the C1 of T? C1 of T, this one. Apply the Laplace transform for this one. Apply the Laplace transform for this one. 1 means 1 by S, e power minus 2t means 1 by S plus 2. So 1 by S minus 1 by S plus 2. This is the what? C1 of S. C1 of S. Okay, na C1 of S upon R1 of S, tell me. R1 of S, tell me, anyone. R1 of S. Where is R1 of S? R1. Alpha into U of T. Alpha, U of T means 1 by S. Alpha, 1 by S here. So take the LCM, S plus 2 minus S by S into S plus 2 into alpha. This S in the numerator. This S in the numerator. 1 by S, S is in the numerator. Now please help me here. Hello guys, please help me. SS cancel. So SS okay, cancel here. So overall what is our transfunction? 2 by S plus 2 into alpha, correct na? Into alpha. This is G1 of S, equation number 1. Next, second transfunction G2 of S equal to C2 of S by R2 of S from the given diagram. Once check it. C2 of S by R2 of S, G2 of S. Please help me here. What is the C2? C2 equal what here? 4 into e power minus t. 4 by S plus 1. Laplace transform. 4 by S plus 1 guys. Okay, 4 by S plus 1. 4 by S plus 1. This is the one transfunction. Okay, 4 by S plus 1. Again R of S, R2 of S. Please help me. R2 of S. Where is R2 equal to? Beta into delta of t. Beta Laplace transform, beta constant, del of t. Impulse signal is 1 only. So be simple beta only guys. Simple beta only guys. What is the answer? You get, come on, tell me. 4 by beta into S plus 1. Both are cascaded means overall transfunction equal to overall. Both are cascaded and overall equal to. What is the examiner is asking? Both are cascaded means overall. Overall is what? Overall equal to G1, G2 guys. G1, G2 means equation number 1 and equation number 2. 2 into 4. 2 into 4. 2 into 4 upon denominator. Alpha into beta. Alpha, beta, S plus 1 into S plus 2. This is a multiplication of equation number 1 and 2. But what is the given standard is given? Overall transfunction G1, G2 in the question paper is given 1 by S plus 1 into S plus 2. Given 1 by S plus 1 into S plus 2, examiner was given. Okay, it is given. We obtain. So cancel all the term. S plus 1 cancel. S plus 2 cancel. So what happens here? 2 into 8. Alpha into beta equal 2 into 8 equal 8 is the correct answer guys. 8 is the correct answer dear students. Alpha into beta equal 8. So obviously what is the option here? Come on, tell me. Option D is right answer. Option D is right answer dear. So here correct answer is option D. Okay, option D, simple question. So these are the questions for BARC mark test 1 from the control system.
From the digital electronics, okay. See the question number 1. In the circuit shown below, assume the initial data 0, 0, then the states of the counter Q0, Q1 respectively. Immediately after the 112th clock pulse, what is the output? He is asking about the states Q0, Q1 respectively after 112 number of clock pulses. First of all, maybe 100 or 112 or 700 or 1000 clock pulse data if you want to find for a given counter. The simple point is we need to identify the modulus number of the counter. You know, after modulus number of clock pulses, counter will automatically restarts from its initial state, as given initial state is 0 0, and there is one feedback here from the output of Q1 bar, and K of a first flip flop is permanently connected, second flip flop inputs are directly taken from the output of a first flip flop. Okay, very simple. Let me take Q0 and Q1 here. While giving the initial data, we are not providing any clock. So, this is the initial data. Let me write, instead of taking the separate table, I'd like to overwrite the sequence, right, on that circuit. So, what is this data? 0, and this is also 0. If this is 0, its complement is 1. Okay. What are the inputs of first flip flop? Do not apply the clock, first you verify the inputs, 1 and 1. Now, you think, what if a clock is applied? If a clock is applied, the first flip flop is going to toggle. At the same time, simultaneously, the second flip flop also will take that decision. Sir, why sir? Why? Because clock is given for both the flip flops from the same source. 0, then this is 1. Input of second flip flops are 0 1. So, output will also 0 1. Okay. So, if I apply the clock, first flip flop toggle. So, 0 toggle means complement of previous. At the same time, do not apply the next clock. Okay. So, at the same time, this 0 1 will transfer to the output of second flip flop. So, again Q1 value will be 0. This is happened after first clock pulse. First clock pulse. Now, update the data. 0, next data is also 0 here, 0. So, this is 1. So, the next feedback also 1 here, but this is already updated, you know. What is the Q0 value? 1. So, that updated data is 1. So, this is 0. Now, if you apply clock, what will happen? As again J value of first flip flop is 1 and K is 1, first flip flop will toggle, but this time second flip flop inputs are 1 0. After clock, output will be 1. Okay. So, that I am applying second clock pulse. If you apply the second clock pulse, what is going to happen? Same, first Q0 will be toggle, 1 complement 0, and same 1 will be transferred to the output. This is 1. Let me update the data. This will be 0 and this is 1. Okay, and this is 1 and 0. Updated data is available. Now, you see what will happen if you apply the clock. What is this value? Q1 bar 0. 0 is available for the first flip flop. So, 0 1. If you apply clock, 0 1 will come to the output. Similarly, for the second flip flop also inputs are 0 1. So, very simple. 0 and 1 are the inputs for both the flip flops. The moment you apply the simultaneous clock, zeros will transfer. That means, if you apply third clock pulse, 0 0 will come, but the 0 0 is already the initial state. How many states available? 3 states. So, given is a mod 3 counter. So, this is a key point. After 3 clock pulses, every 3 clock pulses, counter will come back to its initial state, that is 0 0, right. But we need to find the sequence after 1 1 2, that means 112 clock pulses. So, you have to take the multiplication of 3 with some number, which should be an integer multiple of 112. Of course, 3 odd number may not be possible, at least you will get the nearest number. So, 37 times that of 3 is how much? 111, right? 111. So, what does it indicates? 37 times counter can restart from initial state. So, by that time counter value will be 0 0, but you need the output at 112, that means you add another clock pulse. After one more clock, 112, next state will come. After 0 0, what is the state? 1 0. 1 0 is the state. So, that I have taken Q0 Q1, he is also asking Q0 Q1. So, that answer is 1 0, B is the correct option. got it. So, please verify the solution. I will go for the next question. See, how many minterms excluding redundant terms? If you find any repeated terms, you can ignore it in the minimal switching function of this. Here you should observe this point carefully. Given is a 5 variable function. There are different ways. For example, you can start like this: V, W, X, Y, Z. For example, we have only X, Y. That means what? V is missing, don't care. W is missing, don't care. X is available, I am taking small x just for reference. Otherwise, you may confuse it as don't care or X, okay. X, and then Y is also available, Y, and then Z. Z is not available here, Z is missing, so that you take missing variable as don't care. We have X and Y, that means this is 1, 1, appeared as minterms 1, right. So, don't cares can be considered as zeros and ones. You take all possible combinations, 000 to 111, you will get some minterms. Similarly, here also if you do, you can find the repeated total number of minterms. If you find any minterms, you can remove them. This is one method. And alternative method is, I am using K map, okay. You take a 5 variable K map. So, we need to take 2 4 variable K maps, you know, and you also know that how to map them. So, what is the MSB bit here? MSB bit is V. I can write it as V bar and V and the remaining terms Wx, W bar X bar, W bar X, Wx and Wx bar, Yz, Y bar Z bar, Y bar Z, Yz and Yz bar. You should maintain the same sequence here also. So, this is the result in fact, okay. This is the result, xy plus y bar z is obtained. What might be the minterms involved? Simple, you just think in reverse, right. By taking a 5 variable K map, assume that after minimizing a function, this is obtained result. What might be the minterm have been like grouped or involved in the K map? That many number of actual minterms available in the original function, like that also we can think. This is an alternative method. In class generally we have discussed multiple methods, method 1, method 2, method 3, and this is actually the method 2 from the class notes. Okay, let me take this xy. How can I get xy? Look at this man, this is x. How can I get xy as common? This is y. If I take the minterms here, I can get, you see, common term xy, but it is not xy, xy dot v bar, but we have only xy, we do not have v bar. How can you overcome the v bar existence in the result? You take the same copy into the next K map, because it is 5 variable K map, okay, like this. Next, what is the next answer? I mean next minterm in the result, y bar z. It is directly available, you see, y bar z. If you take this minterm, this is going to be y bar z into v bar. I want y bar z only, so that you take this here in the second K map also, like this, y bar z over. If you group this K map, you will get this answer. That means this is a question. This question is nothing but standard SOP function, in which you can find the number of minterms. How many minterms are available? 4 plus 4, 8, 4 plus 4, 8, right. So, that total 16. Total 16 terms are available. Option A. Option A is correct. Let me go for the next question. A temperature in the range -40 to 55 degrees is to be measured with a resolution of 0.1. Of course, resolution may be volts, may be milliamperes, may be degree centigrade. In this experiment, he has given the resolution 0.1 degree centigrade. Of course, the minimum number of ADC bits required to get required to match the dynamic range of a temperature sensor, right. So, just to remove this, required to get a dynamic range. So, we need to match the number of bits, right, without any shortage of bits in order to get this accuracy. And actually the project range of temperature is -40 to 55 degrees. Actually the we have a resolution here. you know a formulae between the resolution and the number of steps. So, number of steps is equals to full scale voltage. Full scale voltage are we can call it as range, strictly speaking, generalized formula range by resolution. Range by resolution, or otherwise resolution equals to full scale voltage by number of steps 2 power n minus 1. I think you may remember, in general we are doing that, right, with a voltage, but here we have doing with temperature. So, first of all you need to identify the range of temperature. What is the range of temperature? 55 minus 40 degrees. So, 95. This many number of stages of temperatures we can see, minus 40 like or plus 55, plus 54 or 0 or 1 like that, totally 95. Number of total range is 95. Then you can directly substitute it. So, the steps formula you know well, 2 to the power of n minus 1 is equals to, what is the range? 95 divided by, what is the resolution? He has given that, look at this, 0.1. So, 2 to the power of n minus 1 is equals to, or maybe greater than or equals to, we can write while finding the n value. Even if you use more number of bits, no problem, but there should not be a shortage of bits for the given experimental result. Okay. So, this is equals to 950, 0.1, okay, 950. So, that 1 by 10. So, 2 to the power of n should be greater or at least equals to 951. If you take n value as 9, 2 to the power of 9, 2 to the power of 9, 512. So, not matching, it is not sufficient. If you take 10, that will definitely matches the range, because even there is a shortage, even there is a excessive value, no problem, there should not be a shortage value. So, that, sir, 12 and 14 also correct, of course, you should match it, at the same time you should select the minimum number of bits. Okay. So, in all aspects we can select option B. So, we need 10 bits for this given ADC, then only it can match with the given resolution, right. In the given circuit, find the frequency at output Y naught. This is a direct question here, but actually you see, please observe it carefully, this is actually a counter, okay, it is not single flip flop, it is a counter, direct 4-bit Johnson counter, input and output is given. Sometimes they can give you this type of symbol also, no need to worry. Okay. So, for this counter we have 20 megahertz of input. What is the output frequency of a counter? Generally input frequency divided by modulus number. But if two counters are connected, see, this is a toggle switch means it is a mod 2 counter. What is the modulus number of Johnson counter? 2 into n. What is the n value? 4 bit, 2 into 4, 8. Okay. So, that you can find, you see here you can find the frequency, input frequency 20 megahertz divided by 8, 2.5, right, 2.5 megahertz, right. Then what is the output here? This input frequency divided by its modulus number, 2.5 megahertz by 2, 1.25 megahertz. So, it is a direct question, 1.25 megahertz. B is the correct option, right. And find the output Y naught, very simple and straightforward question. Active low enabled type controller is connected to ground, means this multiplexer is in active state. So, what are the values of information lines? I naught is equals to I1, you see these two are connected, okay, like this. I naught I1 is equals to 0. I2 value 0 complement, I3 also 0 complement. I2, I3 value is 1. S1 is permanently connected to complement of 0, that means 1. So, what is a Y0? S1 is 1, we cannot change it. Generally, what is the expression? Y0 is equals to S1 value is 1, okay, 1 into B. B can be either 0 or 1. B is a variable, but S1 is no longer a variable, it is just a 5 volts or logic one. So, that 1 into B bar. So, that 1 into B bar plus 1 into B. So, that means what? 1 0 pin number 2 and this is 1 1 pin number 3. 1 1 means pin number 3 and this is pin number 2. So, what is the content of pin number 2? Content of pin number 2 is 1. Pin number 3 content also 1. So, that you can write, or otherwise you can write in terms of B also, no problem. Okay. So, B bar into 1 plus B into 1 into 1. So, what is the Y0? B plus B bar value is 1. In that way also output will be fixed at logic 1. So, B is the correct option, right. Output is always 1. Next, this is the standard question here. S1, S0 value of 8085 microprocessor or 0, it will shows the halt state, right.
So, please go through the question. Find the average power dissipated in the 30 ohms resistance where the diode is ideal in milliwatt, right. Mind you, the units here is in milliwatt, okay. The diode is treated as ideal and you are asked to find the power dissipation in the 30 ohms resistance. So, what is the power dissipation formula? Power dissipation is IRMS square into R. And what is IRMS for half wave rectifier? For half wave rectifier, IRMS equal to IM by 2. IM by 2. So, let us find IM first. For finding IM, what is the peak input voltage? The peak input voltage Vmax is 10 volts. So, what is IM? IM is going to be 10 by 10 plus 30 plus 20, which is 1 by 6. So, let us substitute here 1 by 6 by 2, it is 1 by 12. 1 by 12. So, what is IRMS if we substitute? IRMS is 1 by 12 whole square into 30 ohms. So, this is the solution. So, let me use the calculator. So, it is 30 divided by 12 square, 144. It is 208.3. 208.3. The units of power is watt, milliwatts. So, I repeat, this is a half wave rectifier. You are asked to find the power dissipation, and we know the power dissipation formula is IRMS square into R. And what is IRMS for a half wave rectifier? It is IM by 2. IM by 2. Now, go through the question. The frequency of oscillations generated by the circuit in hertz. So, this is a standard stable circuit, and if this is R and this is C, and here you have R1 and R2, the time period is given as -2 RC log R1 by R1 plus 2R2. So, this is a standard formula. So, if you want we can derive this also, but this is a very standard formula. So, let us substitute minus 2 R is 1K into 1 micro log 10K by 10K plus 2 times of 10K, 20K. So, it is going to be 2 milli log. So, I will remove the negative sign, 1 by 3 becomes 3. So, it is log 3 is already given 1.1. So, 2 milli into 1.1. So, this is the time period, but we are asked to find the frequency. What is the relationship between time period and frequency? F is 1 by t, 1 by t. So, it is going to be 1 by 2 milli into 1.1. So, let us calculate this. 1.1 into 2, 2.2, 1000 divided by 2.2. 454 I am getting, 454.5. So, it is 455, option B. The units of frequency is hertz. The units of frequency is what? Hertz. So, let us go through the next question, or you can as well derive this. What if this plus V is say plus 10 volts, minus V is say minus 10. Then this voltage, if this is plus 10, you will have plus 5. If it is minus 10, you are going to have minus 5 by voltage division. So, if you want, you can, the output is going to give you a square wave between plus V and minus V, plus V and minus V. So, what happens here? This capacitor is going to charge towards plus V, but when it crosses V by 2, then if the voltage at inverting is more than non-inverting, the comparator, the output will flip from plus V sat to minus V sat. So, similarly, in the negative side, this is going to be minus V by 2. So, if the whole duration is t, then half of it is going to be t by 2. So, how do you find? The voltage across a capacitor for all time is V initial minus V final, which is plus V, e power minus t by tau, tau is RC, plus V. At time t equal to t by 2, you are going to land up at V by 2. So, from minus V by 2, from minus V by 2, you are going towards plus V. So, what happens at V by 2? V by 2 is minus V by 2 plus V, e power minus t by t is t by 2 RC plus V. So, from here you can find t. T is going to be minus 2 RC log 1 by 3. So, like this also you can solve, and inverse of time period will give you the frequency. Go through the question. For an NPN transistor, the current gain alpha of the transistor is equal to 0.996. If the value of collector to base leakage current when emitter is open is ICB0, then the value of collector to emitter leakage current when the base is open. So, this is a simple substitution problem. ICE0 equal to 1 plus beta times of ICB0. But what is beta? Beta in terms of alpha is alpha by 1 minus alpha. into ICB naught. So, let us substitute 1 plus alpha is 0.996 by 1 minus 0.996 into ICB naught is nano, 2 nano. Nano is 10 power minus 9. So, you can use the calculator now. Uh, 0.996, 1 minus 0.996, 0.996 divided by 0.004 plus 1, 250 into 2 is 500 into 10 power minus 9 I am getting. So, we want this in micro, micro, so it is 0.5. Now, this volt is wrong here, this is the correct answer, the answer is in micro. Now, go through the question. For the transistor circuit shown, VB is 0.7, beta is very high, then the value of V naught in volts. So, you are asked to find V naught here. VB is 0.7 volt. So, this is going to be minus 0.7. So, what is the current here? Minus 0.7 by 1K minus 0.7 milli. So, the total current here, emitter current, is the summation of these two currents. 2 milli minus 0.7 milli is 1.3 milliampere. So, this current is also 1.3 milli. Since beta is large, emitter current and collector current both are same. If 6 milliampere is flowing here, this is 1.3, then this should be 4.7 milli. So, what is 4.7 into 1K? 4.7 volts. So, this is the right answer. So, first we have found the emitter current, the emitter voltage, then the emitter current. Emitter and collector current both are same because the beta is given very high, right. For the op-amp circuit shown, calculate the output voltage. Calculate the output voltage. So, how will you solve this problem? Okay, so here you can see there is a current source. This current is split into two currents, I1 and I2. And this potential and this potential both are same. Suppose this node is Vx, this node is Vy. So, this is also Vy. So, you can see Vx minus Vy is this drop, Vx minus Vy is this drop. So, the voltage across this and the voltage across this both are same. So, what is the total current? The total current 1 milliampere equal to I1 plus I2. And I1 into 2K equal to I2 into 3K equal to Vx minus Vy. So, or if you remember current division formula, you can directly use it without solving. So, if you solve it, you will get I1 equal to total current into opposite arm resistance by sum. So, this is 0.6 milliampere. Then I2 should be 0.4 milli. So, let me check 4 3s is 12, 6 2s is also 12. So, this drop and this drop both are same. Now, since this node is Vy, this is also Vy, the difference is 0. and this current is also I1, this is also I2, and you are asked to find V0. You are asked to find V0. Now, how do you solve for V0? You can apply KVL if you wish, like this. So, KVL minus I1 into 1K plus 0 plus I2 into 4K plus V0 equal to 0. So, I1 is 0.6, I2 is 0.4, 4 4s are 1.6 minus 0.6. So, your V0 is minus 1 volt. So, you can substitute I1 and I2, your V0 is minus 1 volt. And if you wish to calculate Vy is I1 into 1K. If you wish to calculate Vx, it is I1 into 2K plus 1K, if you wish to calculate. Now, this is a current mirror circuit. In this circuit, Q1 and Q2 are matched transistors with VB is 0.7, beta is 50. Then the value of I1 by I2. So, how will you solve this? Now, since VBs are same, their IC should also be same. If this is IC, this is also IC. So, the base current is going to be IC by beta. This current is also IC by beta. So, the total current is going to be 2 IC by beta, because entering current is leaving. So, what is I1? I1 is IC plus 2 IC by beta. It is IC, IC is nothing but I2, IC is nothing but I2. So, the question is find I1 by I2. I1 by I2 is 1 plus 2 by beta. Beta is 50. Beta is 50. 1 plus 2 by 50. So, it is 52 by 50. It is going to be 52 by 50. So, what is 52 divided by 50? It is 1.04. Option B is the right answer. Now, go through this problem. This is a Wien bridge oscillator. It is a standard circuit. The value of R required for the sinusoidal oscillations of frequency 1 kilohertz is. So, for a Wien bridge oscillator, what is the oscillating frequency? F equal to 1 by 2 pi RC. But you are asked to find R, which is 1 by 2 pi FC. 1 by 2 pi, F is 1K, 10 power 3. C is 1 micro, 10 power minus 6. So, it is 1 by 2 pi kilo ohms. It is 1 by 2 pi kilo ohms. Option D is the right answer. Simple formula, a standard Wien bridge oscillator. An amplifier has an open loop gain of 10, input impedance of 0.5 kilo ohm, output impedance of 200 ohms. The feedback network with a feedback factor 0.9 is connected to the amplifier in a voltage series feedback. The input and output impedances are. So, what is the desensitivity factor? 1 plus A beta. A is 10 and the feedback factor beta is 0.9. It is 10. Now, since this is a voltage series feedback or series shunt feedback, input resistance should be input resistance of the basic amplifier multiplied by 10 times. So, it is 0.5 kilo ohm into 10, it is 5 kilo ohm. The output resistance is going to be output resistance of the basic amplifier divided by 1 plus A beta. The output resistance is 200 ohms by 10, it is 20 ohms. So, 5 kilo ohm and 20 ohms. Find Rx for sustained oscillations for the oscillator circuit shown below. So, you can calculate the loop gain and do it, or another simple shortcut technique is whenever an oscillator generates an oscillating frequency, it should be a parallel resonant circuit. So, this is a simple parallel resonant circuit. At the oscillating frequency, this LC acts as open circuit. LC acts as open circuit. So, when this is an open circuit, if this is V1 and V2, so what is loop gain? The loop gain is V1 by V2 into V2 by V1 is 1. V1 by V2 into V2 by V1 is 1. V1 by V2, this is a non-inverting amplifier, 1 plus 9K by 1K. V2 by V1, so this is V2. So, this network is an open circuit. You can apply the simple voltage division, 0.5K by Rx plus 0.5K is 1. So, this is 10, 10 into 0.5 is 5, Rx plus 0.5 is 5, Rx plus 0.5 is 5. So, what should be Rx? 4.5K. 4.5 kilo.
Hello students, so here we are going to see the solutions from signals and systems subject. This is from BARC mock test 1. So here is the question. The impulse response of an LTI system is shown below. So this is the impulse response at SIPs. They want the step response. Now you observe the impulse response. There is an impulse at -2 and there is also an impulse at t equal to 2. Can you get an expression for this? Since there are two impulses, you can write h of t equal to, so del of t plus 2, and then look at this impulse is facing down, so it's minus del of t minus 2. This is how you write h of t. How is s of t and h of t? S of t is a step response and h of t is the impulse response. How are they related? You can obtain the step response like this, minus infinity to t h of tau d tau. Integrating impulse response will give you step response. Integrating an impulse like this will give you u of t plus 2 minus integrating this will give you u of t minus 2. This is very standard, everyone knows this. Can you draw this? How does this look like? How does this look like? Clearly, it's a rectangular function. What shape? Rectangle from -2 to 2 with a height 1. So, this is the step response. So, what is the shape? It's a rectangular function. What's the width of this? 4. So, in this is the standard notation where we represent a rectangle whose width is 4 and the height is 1, the coefficient is 1. This is the right answer to this question. continuous time Fourier transform does not exist for. So you have to observe this carefully. From this, look at this signal. If you try to sketch this e power 2t into u of t, do you know what's the graph? The graph is like this, which is exponentially increasing function. Exponentially increasing function. So this is not absolutely integrable. If you have exponentially increasing functions like this, the Fourier transforms are not defined. So the remaining are all absolutely integrable, no issues with this, but this is not absolutely integrable. This will not have a Fourier transform. The Nyquist rate of an analog signal g of t for alias-free reconstruction is 5000 samples per second. For a signal x of t equal to g of t whole square, the Nyquist rate of x of t in samples per second is. The Nyquist rate of g of t is given. Did they give the Nyquist rate or the maximum frequency of g of t? Come on. Did they give you the Nyquist rate or the maximum frequency of g of t? Nyquist rate of g of t is given. So let us assume that let Fm be the maximum frequency of g of t. Let Fm be the maximum frequency of g of t. Then according to the sampling theorem, the Nyquist rate of g of t, Nyquist rate of g of t is 2Fm. And this Nyquist rate is given, that is 5000 samples. From this, Fm is 2500. The maximum frequency of this band limited signal is 2500. So let me just take some shape, random shape. This is minus 2500. This is 2500. This is F domain, which is in hertz. What is this? This is the Fourier transform g of f. You know g of f. How is x of t created, students? X of t is simply g of t whole square, which is g of t into g of t. We all know multiplication in time results in convolution in frequency. So the Fourier transform of this will be like 1 by 2 pi g of omega convolved with g of omega. Since this is in f, so what you can do is you can directly write like this: g of f convolved with g of f. If you want to comment about the Nyquist rate of x of t, then you need to have an idea of what is g of f convolved with g of f. Do you know g of f? Yes, a triangle. I mean, shape is irrelevant. So minus 2500 to 2500. Some shape convolved with again the same shape. What does the convolution rules say? If you are convolving two things like this, the new waveform, so it will start at a value. Suppose you want to know where it starts, you have to add these two values. Adding this will give you minus 5000. Adding this ending values will give you 5000. So some shape is irrelevant. The maximum frequency, and this is like x of f, students. The maximum frequency of x of f is 5000. Therefore, the Nyquist rate would be twice of that. So the Nyquist rate of x of t is 2 into 5000, which is 10,000 samples per second. Do we have such options? Yes. So this is the answer to this problem. If x of t is e power minus 3t u of t plus e power 2t into u of minus t, then the Laplace transform as well as the ROC is dash. So what is the Laplace of the first one? The Laplace of the first one is 1 by s plus 3. What's the Laplace of the second one? You have to be extremely careful. There will be a minus sign, minus 1 by s minus 2. What's the common, what's the ROC of the first term? This is from the right sided part. So sigma greater than minus 3 intersection with the ROC of this is sigma less than 2. You need to search for the common ROC. Yes, there is a common ROC here, that is minus 3 less than sigma less than 2. And you have to simplify this. Some students will ask, how did we get? You draw the two ROCs, see where is the common part, you will see that this is the common part. take the LCM, s minus 2 minus s minus 3 divided by s plus 3 into s minus 2. So this and this cancels, you have minus 5 by s plus 3 into s minus 2. So do we have such options? So this is gone, this is gone, the two options are there, and the common ROC is minus 3 less than sigma. Sigma is nothing but the real part, so this is gone. So the answer is option B. Express the Z transform of y of n, which is k from minus infinity to n x of k. This is clearly a direct property, accumulation property. So what does the property say? According to Z transforms, if x of n Z transform is x of z, and then you go for the summation like this, k from minus infinity to n x of k. So according to accumulation property, the Z transform of this is, it is x of z into z by z minus 1. It has, you can simplify this. Is there any option matching like this? Z by z minus 1? No. So we have z power minus 1. So if I like take z common and then simplify, this will be like x of z into 1 by 1 minus z power minus 1, which is with this option C, x of z by 1 minus z power minus 1. Directly accumulation property. What's the time period of x of t? What did you learn in the classes? Observe these terms properly. It is 6 e power j, okay, 4t, and here it is e power j 3 pi t. Clearly there is pi here, there is pi here, and there is no pi here. And you analyze t1 by t2, that t1 by t2 won't be a rational number. So clearly this is a aperiodic signal. So for aperiodic signals, we don't have any time period. This is the simplest way to solve it. If you want, you can check t1, t2, take the ratios, it would be irrational. So the answer is not periodic. They gave a periodic signal and they're asking what's the fundamental frequency. You can do it in many ways, the easiest ways. So what are the frequencies here? The frequencies are 5 pi, 13 pi, 20 pi. Take their GCD. So take their GCD. The fundamental angular frequency is given by GCD of all these fellows. What's the greatest common divisor? The greatest common divisor of 5, 13, 20 is 1. And the greatest common divisor of pi is pi. So the GCD is pi. Therefore, the fundamental angular frequency is pi. But we want that in hertz. So if you want in hertz, f naught is omega naught by 2 pi, which is pi by 2 pi. 1 by 2 is 0.5 and the units are hertz. So very simple problem. So the answer is option A.
Hello, welcome to the session. Here we will discuss the questions which were asked in BARC Mock 1 examination. The questions I am going to discuss from the subject electrical machines. I have around 13 questions, so we'll look at those questions. The question is given as like this. A 20 kVA 2000 by 200 volt single phase transformer has percentage resistance of 2% and percentage reactance of 6%. Now he is asking to maintain the load side voltage as 200 volts at full load 0.8 power factor lagging, the voltage required to be applied on the primary side of the transformer is. Okay, so this is the voltage, these are the voltage ratings of the transformer. It's 2000 by 200 volts, it's a step down transformer. To say exactly, these are induced EMFs on the high voltage and low voltage side. So I can say that it is E1 and E2. Okay, so he is saying that the percentage resistance drop and reactance drop, that means what if the if there is a winding resistance and leakage reactance in the transformer windings or in the transformer, there will be some drop. Okay, right. So if you are getting this much drop, to maintain the voltage across the load as 200 volts, what amount of voltage to be applied on the primary side? That is what he is asking. So if I look at the transformer simple diagram. It's a high voltage winding and it's a low voltage winding. So this is my 2 kilovolts on the high voltage side, and this is my 200 volts on the low voltage side. Okay. So definitely you will be having a drop, right? The percentage or per unit impedances on both the sides will be same. So let me take up the resistance and reactance on the primary side. Okay. You will get some drop here, you will get some drop here. So some voltage drop will be there. So this I am writing it as VD. Okay. Now to maintain the terminal voltage or to maintain the load voltage as 200 volts, across the load, what is the amount of voltage you need to apply on the primary side. So this V1 is asking, okay. If you apply 2000 here, there will be some drop in the transformer winding resistance, and due to leakage reactance there will be some drop. After that drop, the EMF which will be available across, the EMF induced will be lesser than the 2000, and therefore the secondary induced EMF will be less than the 200, and hence the terminal voltage will be less than 200. So to maintain this terminal voltage as 200, you should increase the voltage more than 2000. You should apply the voltage more than 2000. How much voltage you need to apply? This 2000, if you get a EMF of 2000 here, you will get a voltage of 200 here. So if you want to get 200 volts on the terminal or load side, you need to apply more than 2000. What is that more than 2000 value? Its EMF value plus drop is equals to this V1. Okay. So how do you find out this drop? You have a regulation formula. So the formula for percentage regulation, if you take up percentage R cos phi 2 plus or minus percentage X sin phi 2. As is asking for lagging power factor, the drop, this percentage regulation formula will be having positive sign. If it is for leading, then it will be negative. Okay. So I have resistance term around 2%, and the power factor at which the load is operating, it is 0.8. Okay. Plus percentage reactance is 6% into, if cos phi is 0.8, sin phi will be 0.6, na? Right. So you will be getting, this is 2 8s is 16, maybe 1.6, and this is 6 6 is 36, so 3.6, 1.6% plus 3.6%. So you will be getting it as for 5.2%. 5.2% of what? 5.2% of what? Okay. So you can take up, regulation can be what? No load voltage minus load voltage divided by load voltage you can take up. Okay. So I am taking like this, E1 minus no load voltage, V1 minus E1 divided by, you can take up V1 or otherwise E1, doesn't matter. It doesn't give much change. Okay. So now we need to calculate this V1. I know E1, right? How much is that? 2000. So you can take up V1 minus E1 is equals to 5.2% of E1. What is E1? 2000, right? So 5.2% of 2000. So you will get this as around 52 times 2, you will get this as around 104 volts. I want V1. So V1 is equals to 104 plus E1. So E1 is how much? 2000. So you will get it as 2104 volts. So this is the amount of voltage you need to apply on the source side, so that you can get the load voltage as around 200 volts during full load, when the power factor of the load is 0.8 lagging. Okay. I hope it is clear. So by looking at the options also, you can eliminate at least few options, right? Definitely the voltage applied must be greater than 2000. So the answer should not be less than 2000. The answer must be greater than 2000. It should not be less than 2000. So I can eliminate at least one option here. That way you can do. Remaining all are more than 2000 only. So you should be careful. So by the time you solve this EMF, that is regulation value, so 5.2% of 200. So you will get 104. So definitely 2000 plus 104 could be the answer. We will see the next question. The following characteristic is drawn for a 200 volts DC shunt motor between speed and torque. So, he has given between speed and torque, the characteristics he has given. Now, he is asking if an additional resistance of 1 ohm is added into the armature circuit, okay, the stalling torque is dash. What is the amount of stalling torque? Stalling torque means what? Stalling torque means what? The electromagnetic torque produced by the motor when the motor is coming to 0 speed or when the motor is about to come to rest. Okay. So, during stalling condition the speed is 0, remember that point. During stalling condition speed is 0. If speed is 0, there is no rotation of armature conductors. If there is no rotation of armature conductors, will you get any flux linkages, change in flux linkages? No, and hence EMF will be 0. So, if speed is 0, back EMF during stalling is also going to be 0. Remember this point. We want stalling torque, okay, we want stalling torque. Generally, remember, if you want to solve any problem in the DC machines, there are there are 3 powerful equations which you need to remember. Power is equals to torque into omega, and torque is equals to K phi Ia, EMF is equals to K phi omega. Of course, as I said, power is equals to torque into omega. These 3 are very powerful equations. He is asking to calculate stalling torque, okay, and here he has mentioned that it is a DC shunt motor. If it is a shunt motor, generally flux is a constant value. So, here I can take up flux as constant value. If the flux is constant, I can write torque is equals to K into Ia. So, if you want to find out stalling torque here, the stalling torque can be taken as K into stalling current, K into stalling current. So, you need to calculate K value, motor constant and stalling current. Okay. How do you calculate this motor constant? How do you calculate this motor constant is a question. Okay. From the characteristic equation, is there any possibility to find the motor constant? Let us see. See here, the torque value he has mentioned 20. When the motor is developing torque value of 20, the speed of the motor is 400 radians per second. But when the torque developed by the motor is 0, the speed of the motor is going to be 500 radians per second. So, it is nothing but no load condition he has given and load condition also he has given. So, let us take up the information according to that. He has mentioned it is a shunt motor. So, I am drawing an equivalent diagram like this. I have an armature resistance, I have a back EMF, and of course, I have a shunt resistance. Did he mention any supply voltage here? Did he mention any supply voltage? Yes, he has mentioned it as 200 volts. Okay, right. Now, the no load condition, let me take up no load condition. So, if I go ahead with the no load condition, if it is no load condition, generally, the current drawn by the motor is going to be almost negligible. It will draw some current practically, but if it is not mentioned if it is not mentioned in the question, no load current, if he has not mentioned, then take up the no load current as armature current drawn is going to be 0. So, that the electromagnetic torque developed under no load condition is also going to be 0. What is the no load speed omega naught? He has mentioned it as 500 radians per second. 500 radians per second. If the current drawn by the motor is going to be 0, will you get any voltage drop here? No voltage drop across the armature resistance. Then I can say that the back EMF under no load condition will be equals to supply voltage or not, because you apply KVL, V minus IARA is equals to EB. So, the back EMF I am going to get it as 200 volts. Okay. I know the no load speed. Now, when you know the no load speed and no load back EMF, can't you calculate the K value? Because we have equations, 3 powerful equations, T is equals to K phi Ia, E is equals to K phi omega, like that. Coffee equations, K phi, we also call them as coffee equations. Okay. So, EB naught is equals to K into omega naught. I am not writing here phi because phi is going to be generally constant, because the supply voltage across the shunt field winding will not change and hence flux also will not change. So, now I can take up the K value here. How much is the K value? EB naught, I am going to get it as 200, omega naught I have got it as 500. So, we will be getting the K value as around motor constant as around 0.4. If you want to write the units, you can write volt second per radian. That is also fine, because this is volt and this is radians per second. So, volt second per radian, the motor constant units you can take. Okay. Anyhow, I have got the information as motor constant value. What is the other thing I need? What is the other thing I need? The other thing I need is, along with the motor constant, I need the current drawn by the motor during stalling condition. Okay. So, let us do that. Now, if I have a during stalling condition, okay. So, let me take up stalling condition. Let me draw the diagram. During stalling, he is inserting an extra resistance also. So, RA plus R external, RA plus R external, yes or no? If an additional resistance of 1 ohm is added into the armature circuit, what will be the stalling current is asking. So, RA plus R external, let me take up external resistance, how much I am keeping? 1 ohm. RA, do you know RA? No. Back EMF during stalling. Is there any change in voltage? He did not mention. So, let us take up it as 200. Is there any change in shunt field flux? No, not mentioned. So, let us take it as it is constant. Okay. So, here during stalling the speed is going to be 0. So, the back EMF is also going to be 0, right. Now, here I need to calculate the stalling current here. To calculate stalling current, what you have to do? What you have to do? Potential difference divided by resistance. Current is equals to potential difference divided by resistance. So, the stalling current is equals to potential difference V minus EB, V minus EB under stalling condition divided by RA plus R external. RA plus R external. V value I know, that is 200. EB under stalling condition also I know, that is 0. So, 200 minus 0, 200. RA value I do not know. External resistance I know, that is 1. So, if you can calculate RA value, then you can calculate the stalling current. Now, how do you calculate this armature resistance is a question. Okay. How do you calculate this armature resistance is a question. We have another case also, no load case he has mentioned and load case also he has mentioned. From the diagram or from the characteristics you can take up. This is no load speed, this is load condition speed. Okay. So, from the load you can take up. No. So, during load, if I take up during load, let me draw the shunt field resistance. I did not keep any extra resistance because I am not bringing the motor to 0 speed. The supply voltage is 200 volts. Now, the torque produced during loading, how much torque it is producing? The electromagnetic torque produced is 20 Newton meters. What is the speed during load? The speed of the motor during the load is 400 radians per second. Okay. Now, I know omega, I know the torque value. Okay. I know the K value also. Can't you calculate the current drawn by the motor when it is developing a torque of 20 Newton meters? You can find out, right? T is equals to K into armature current during load. Okay, armature current only. So, T I know, armature current during load condition. So, let me take up armature current during load condition. electromagnetic torque is 20, K value is 0.4. So, you will be getting it as 200 by 4. So, you will be getting it as 50 amperes. So, the motor is going to draw 50 amperes through the armature to develop an electromagnetic torque of 20 Newton meters. But do you want that? No. What I want armature resistance. To find out the armature resistance, potential difference divided by current, you will get the resistance. So, if you want to take up the potential difference, you need to take up EB also. You need to take up EB also. Now, how do you calculate EB? EB is equals to EB under loading condition, let me take up it as EBL, is equals to K into omega. What is the value of K? 0.4. What is the value of omega during load condition? That is 400. So, you can take up 40 into 4, you will be getting it as 160. Yes or no? 160 volts. Now, I can take up potential difference divided by current, you will get the resistance. So, can you tell me how much is the resistance here? 200 minus 160 divided by 50. So, you will get 40 divided by 50, 4 by 5, you will get it as 0.8 ohms. So, 0.8 plus 1, it will be 1.8. So, the stalling current you are going to get it as around 200 by 1.8. So, please substitute 200 by 1.8, definitely it is less than 200 only. Ultimately what I need is torque, stalling torque. So, the stalling torque we are going to get it as, K value is 0.4, the stalling current how much we have got? 200 by 1.8. Solve this, probably you will get this as 44.44 Newton meters. Okay. So, option D could be the probable answer, right. I hope it is clear. You know, step by step this kind of question especially you need to analyze from the given data. He has given no load information, he has given load information. So, from the no load information and load information, what kind of information we can get, or what kind of information we can analyze or solve, so that we can ultimately find out the asked question. Okay, whatever he has asked, that has to be solved. Okay. Let us see one more question. The power supplied to three-phase induction motor is 40 kilowatts and the corresponding stator copper loss is 1.5 kilowatts. The total mechanical power developed and rotor copper loss at a slip of 4%, otherwise 0.04 per unit will be respectively. Is asking total mechanical power developed, generally he has not mentioned mechanical losses. So, it is nothing but total mechanical power developed is nothing but gross mechanical power developed. And is also asking rotor copper loss, generally I will represent PRCU, PCU also fine. Okay. By the time you look at this kind of questions, you should get the power flow diagram in your mind. Okay. So, if you look at the power flow diagram in your mind, we give the supply to the stator. So, this is my motor input Pi. Once the supply is given to the stator losses takes place. So, let me take up it as stator losses PSL. Okay. After the stator losses, the remaining power will be transferred to the rotor via air gap. So, I can call that power as air gap power or rotor input power. Once the rotor receives the power, then some amount of power will be lost in the form of rotor copper losses, rotor iron losses also, but we neglect rotor iron losses because the frequency of induced EMF in the rotor is very less, so we neglect it. And then once the power is lost or some amount of power is lost in the rotor, then it will be transferred to the shaft. So, we call this as gross mechanical power. Once the shaft is receiving the power, it has to overcome the friction and windage losses. So, we call those losses as mechanical losses, and the remaining, the exact torque developed by the motor is called as motor output or shaft output, okay, or motor output, PU, P naught. He has mentioned he has mentioned the induction motor, power supply to the induction motor as 40 kilowatts, which means input he has mentioned 40 kilowatts. He has mentioned stator copper losses also. Did he mention anything about stator iron losses? No. So, let us take up the stator losses as 1.5 kilowatts, 39, 38.5. So, the rotor input is going to be 38.5 kilowatts because stator input minus stator losses, you will get 38.5 kilowatts. What is asking? The gross mechanical power developed is asking, and the rotor copper losses is asking. Okay. At what slip is asking? He is asking at a slip of 0.04 per unit. Okay. Do you know the relation between rotor input, gross mechanical power loss, gross mechanical power developed and rotor copper losses? Yes. Rotor input is to rotor copper losses is to rotor gross mechanical power is taken as 1 is to S is to 1 minus S. He is asking total mechanical power developed. So, gross mechanical power developed can be taken as 1 minus S times rotor input, 1 minus 0.04 times. Rotor input is how much we have got? 38.5 kilowatts. 1 minus 0.04 is 0.96. So, 96% of 38.5. Definitely it is less than 38.5. I hope you solve 38.5. 38.5 less than 38.5. So, I can eliminate this 38.5, 96% of 38.5, this is also cannot be the answer, right? 96% of 38.5 I need to get. I should not get 38.5. I should not get 40. I should not even get 38.4 because 96% of 38.4 is definitely less than 38.4 only. So, ultimately D is the answer. So, if you solve this, you will get this as 36.96 kilowatts. Similarly, is asking for rotor copper losses. So, the rotor copper loss is also what? Rotor copper loss is S into rotor input. So, 0.04 times 4% of 38.5. So, 4% means 4 3 is 12. So, 1 point something, 1.2 like that. So, 1.54, probably it might be matching. It has to match, no other way. Okay. So, option D could be the correct answer. All right. Let us see one more question. He has given a question like this. A 6-pole 50 Hz 3-phase induction motor with a rotor resistance of 0.25 ohms develops a maximum torque of 10 Newton meters. This is my maximum torque of 10 Newton meters at a speed of 875 rpm. So, this is the speed corresponding to maximum torque. Do not say that this is the maximum speed, this is the speed corresponding to maximum torque. The rotor reactance X2 and the slip at maximum torque Sm is asking. So, X2 value and S slip corresponding to maximum torque value you need to calculate. Okay. From the torque slip characteristics, the maximum torque happens when the rotor reactance is equals to rotor resistance. It's same as like maximum power transfer theorem. When the load resistance is equals to source resistance, maximum power will be transferred from source to load. The same way, when the rotor reactance condition for maximum torque during T max, slip times the rotor reactance will be equals to rotor resistance. I know the slip corresponding to maximum torque. Okay, I need to calculate this X2. X2 is equals to this R2 value is 0.25. Now, if you can substitute the slip corresponding to maximum torque, you will get X2. How do you solve slip corresponding to maximum torque? General slip is what? Relative speed. Okay, per unit slip is relative speed divided by synchronous speed. Okay, so slip is equals to ns minus n or rotor speed divided by ns. This is per unit slip. I want slip corresponding to maximum torque. So, you can substitute the speed corresponding to maximum torque, that is it. As it is 6-pole 50 Hz, the synchronous speed is how much? 120 into 50, 120 F by P, na? 120 into 50 divided by 6, you will get synchronous speed as 1000. So, 1000 minus speed corresponding to maximum torque is 875 RPM divided by 1000. So, you get this as around 125 divided by 1000. So, you will get this as 0.125 per unit. There is a slip corresponding to maximum torque. So, you substitute here 0.25 divided by 0.125. 0.125 here one thing and here one thing. So, I can eliminate these two. Okay, right. Probably you can solve, I think you may get it as 2. If you solve it, 0.25 divided by 0.125, yeah, 0.125 times 2 is 0.25 only, no? If you do it 2 times, you will get, it's like 12.5 times 2, 12.5 times 2 is 25, so you will get 0.25, right. So, that way you can eliminate, by solving the slip, you can eliminate 2 options and then you can go ahead with the rest of the calculations, you can find out the answer. Let us have a look at this question. A single phase induction motor is running at n RPM. Its synchronous speed is ns. If its slip with respect to forward slip is, if its slip with respect to forward field is s, what is the slip with respect to the backward field? What is the slip with respect to backward field? Okay. So, generally the single phase, every current carrying conductor will produce a flux, and the flux divides into 2 components, forward field component and backward field component. Okay. So, if my stator is going to produce a flux, so that has forward field component and backward field component, because it is a single phase winding now. So, one winding. So, whenever you drive some current, some flux produces in the forward direction, some flux produces in the reverse direction. Why? You know, it's simple, it's just as simple as like this. Okay. If you drive a current, some flux lines will produce in this direction, because flux always chooses a low reluctance path. This flux thinks that I have a low reluctance path on the right side. The other flux component may think that I have a low reluctance path on the left side, because this winding is surrounded by air. So, the air surrounded by the winding offers equal amount of reluctance, so that the flux gets divided. So, the flux which turns on the right side, let me take up it as forward component. The flux which turns on the left side, let me take up it as backward component. Okay. So, this is how you get the flux split, forward component and backward component. Whereas, this won't happen in the 3-phase induction machines, because you have a 3-phase windings and they have their currents are displaced by 120 degrees and they are forward. Of course, they are displaced by 120 degrees, they are delayed, of course, and that is the reason why you do not get the split. You can see only forward moving waveforms. The resultant strong forward moving waveforms. Okay, resultant quantity will be strong forward moving waveforms. Anyhow, so is asking with respect to backward, the slip with respect to backward field. Okay, right. With respect to forward field, if the rotor is there, if there is a rotor, if the rotor is rotating in the direction of synchronous speed ns, maybe in the direction of forward field with the speed n. So, the slip you can call it as what? Ns minus n. Okay. So, this field is moving in the clockwise direction, rotor is also rotating in the clockwise direction. So, the slip is ns minus n. If it is 1000, 1000 minus 800 like that, 1000 minus 900 like that, slip is very small. Okay. But you see here, if the rotor is moving in the clockwise direction, backward flux is moving in the anti-clockwise direction. So, rotor is moving in the forward direction, backward flux is moving in the backward direction. So, here the difference is increasing, distance is increasing. When rotor is moving forward direction and forward flux component also moving in the forward direction, so the difference is how much? Difference is how much, like this, my left hand, my right hand, flux component, rotor component. So, flux component, rotor component. So, the difference is relative speed is very small, but when one moves, rotor component is moving in the, rotor is moving in the forward direction, backward component is moving in the reverse direction. So, when they move away from each other, the difference is increasing. So, definitely the slip in the backward direction or with respect to backward component will be very large. So, we take up this slip as backward slip as what? This is also rotating at ns na, but with opposite direction. So, I am not taking minus ns, I am taking this rotor speed as minus of minus n, minus of minus n. So, it will be ns plus n, okay, ns plus n. So, this is if you want to take a per unit, the backward slip component in per unit manner, ns plus n divided by ns. So, solve it, ns by ns you will get it as 1 plus n divided by ns. This is like rotor speed na, rotor speed, how will you write rotor speed? Rotor speed is equal to, generally in the forward with a general forward rotation, rotor speed is equals to ns of 1 minus s na. Rotor speed divided by synchronous speed is called as 1 minus s. So, that is what I can write, n by ns can be replaced with 1 minus s. So, you get this as 2 minus s. So, slip with respect to backward flux component will be 2 minus forward slip, 2 minus forward slip. It should be definitely greater, and generally you do not get negative slip, you will find it for generators. Yes, could not be the answer anyhow, because with respect to forward field, if it is yes, with respect to backward field, how come it will be yes, right? So, if you solve, you will get 2 minus yes. This general standard formula only, if you remember you can do it, okay, otherwise that is the reason why I have explained this one. Let us look at this, let us solve this question. A 3-phase star connected alternator is rated at 1600 kVA, 13,500 volts. The armature effective resistance and synchronous reactance are 1.5 ohms and 30 ohms respectively per phase. The percentage regulation for a load of 1280 kilowatts at 0.8 lagging power factor is asking percentage regulation, the same as like earlier only, E minus V divided by V. What is V? What is V? This is the terminal voltage na. As it is star connected or delta connected? Star connected. So, this is my line voltage. So, per phase voltage how much? 13,500 divided by root 3. So, this is my per phase voltage. Now, you need to calculate E. You need to calculate E. The same way here also, RA, XS, and this is my per phase voltage. Sorry, this is my, you can take a per phase EMF. So, if you want to get E, terminal voltage plus this drop na, E is equals to V plus J IA XS, along with that IA RA. Okay, I can take up in this manner also, IA into RA plus J XS and this V. Okay. I am sorry. Here you can use IA, the power factor angle as 36.86. So, IA at an angle minus 30, because it is lagging. So, IA at an angle minus 36.86 you have to do, because virtual calculator will not allow that kind of calculation. So, generally we do not go with this one. We go with another alternative, that is E square is equals to V cos phi plus IA RA whole square plus V sin phi plus or minus IA XS whole square. This actually can be solved from the phasor diagram of a alternator. Okay, right. So, it is like side square plus side square is equal to another side square, hypotenuse like Pythagoras rule. Here, you know, either you can do this way or you know, apply after getting this value, apply root, then you will find E, substitute in the regulation equation, you will get it. Otherwise, there is one more way also. one more way is also there. E, to calculate E, terminal voltage plus drop. So, the terminal voltage how I am doing is cos component plus sine component. Let me show you the phasor diagram also. Okay. What is the load he has mentioned? It is a lagging load, na? It is a lagging load. So, if it is a lagging load, the current should lag the voltage, right? So, let me take up the current here. This is my armature current. Now, the voltage will be somewhere here. This is my voltage V. Okay. So, this is my power factor angle 36.86 degrees. Current is lagging with respect to voltage. Okay. Now, if you add the drop components to the terminal voltage, that will become E. Now, IA-RA, let me draw in a straight manner. So, this is my IA-RA resistance drop and this is my IA-XS reactance drop. So, if you join these two, I can call it as IAZ as synchronous impedance drop. So, this voltage plus impedance drop will become what? Voltage plus impedance drop will become what? The EMF. Okay. So, the angle between E and V you will get anyhow it is delta. So, here what I am trying to do is, I am extending this IA phasor like this. So, this is my voltage phasor na, voltage cos component plus sine component, V cos phi plus J sin phi. Okay. So, that is my voltage magnitude you will get, magnitude of voltage you will get. For that what should I add? IAZS, that is IA of RA plus JXS, the drop component, IA of RA plus JXS. So, solve this and solve this, add up them. V, how much you know? V, how much is that? 13,500 divided by root 3. If you do that 13,500 divided by root 3, you will get it as around 7794. Into power factor, how much he has mentioned? 0.8 plus J sine component will be 0.6. So, you can solve it, probably if you solve it 6235 plus J 4676. Okay. Similarly, the drop component I am solving. Armature current you need to calculate. How do you calculate this armature current? The current delivered by the synchronous generator when a load of how much? Load of how much? 1280 kilowatts only. 1280 kilowatts only. Be careful. You should take up the current corresponding to this given load. Okay. So, the load current will be load power divided by root 3 VL cos phi. So, load power is 1280 kilowatts divided by root 3 times VL is 13,500 into cos phi is 0.8. So, if you solve this, the load current will be around 68.4. Will be around 68.74 or something, yeah, 68.4. Okay. I have got armature current. So, 68.4 into RA plus JXS. RA plus JXS 1.5 plus 30. So, solve this, you will get this as around 103 plus J2052. So, this is impedance drop and this is voltage. You can add up real terms and imaginary terms. If you add up real terms and imaginary terms, you will get the total real term as 6338. So, I am getting voltage as like this, 6338 plus J, if you add imaginary term, you will get this as 6728. Now, once you get this imaginary term or real plus complex term, you take up 6338 whole square, 6728 whole square and applies a root for that. probably you will get around 9243. 9243.1 volts. So, this is the magnitude. So, once you get the voltage magnitude, E minus V. Oh, so I'm sorry, this is E na. We are adding the drop components. So, this is magnitude of E. So, 9243.1 minus 13,500 divided by root 3. We have got it as around 7794. So, if you solve it, you will get it as around 18.6. As it is lagging power factor load, definitely the EMF will be greater than the terminal voltage. If EMF is greater than the terminal voltage, percentage regulation will be definitely positive value. Percentage regulation will be definitely positive value. All are positive he has mentioned. He has mentioned all positive values only. If you solve, you will get 18.6. Okay. Little lengthy, but you know, if you want 2 marks, you need to get it. You need to do this. Okay. Look at this question. Two generators rated at 200 megawatts and 400 megawatts are operating in parallel. Their governor droop characteristics are respectively 4% and 5%. 200 megawatts generator has 4%, 400 megawatts generator has 5% from no load to full load. So, at no load they have equal points. At no load the system frequency is 50 hertz. Now, when supplying a load of 600 megawatts, the system frequency will be dash. Okay. So, if you take up the power plants and if you connect them in parallel, okay, one is 200 megawatts, another one is 400 megawatts, and we are connecting a load of how much? 600 megawatts. Total capacity of the two alternators is 600. I am connecting full load. Okay. But while collecting, whenever you are collecting or whenever you are connecting the loads, one is changing its speed, because whenever you put the load, electromagnetic counter electromagnetic torque for the prime mode torque will be more, because you are putting load, no. So, you are putting load means you are delivering more and more current, the load is drawing more and more current. So, that current can set up a counter torque, that is the reason why the speed falls. So, one is falling with the 4%, another one is falling with the 5% from no load. So, at this point we have 50 hertz. Now, he is asking, when supplying a load of 600, what could be the system frequency? Okay. So, if it is completely 4% fall with 4% droop, how much it is capable? It is capable to deliver a power of 200. Okay. If this generator loses 5% speed or 5% characteristics, then this generator is capable to deliver a power of 600 megawatts. Now, the point is here, is it possible to operate both the generators at this point? No, because at this point generator 400 megawatts generator, this is not 600, this is 400. 400 megawatts generator can deliver the power, but 200 megawatts generator cannot deliver the power because it is out of the limits. So, you should select a point, you should select a common operating point where both the generators can deliver the power. So, I am selecting a common operating point. This common operating point from the no load point, I am taking it as x, the height is x. Now, you can apply similar triangles method. If you apply similar triangles method, you can find out the x value. Okay. On the left side, I am taking, on the left side, if you apply similar triangles method, opposite side by adjacent side. So, you can take up this as P1, you can take up this as P2. So, opposite side by adjacent side, x by P1 is equals to opposite side, how much it is? 4% divided by adjacent 200. So, P1 I am going to get it as around 200 by 4, I will be getting it as 50x. Similarly, right side also you can take up similar triangles method. So, you will get x by P2, x by P2 is equals to 5% divided by 400. So, P2 is equals to 5 8s are 40, yeah, 80x. So, I have got P1 value, P2 value in terms of the common operating frequency. What is the total load on the two generators? It is 600. So, P1 plus P2 is equals to 600. What is P1 in terms of common operating point? 50x. P2 is 80x is equals to 600. So, you can take up 130x is equals to 600. You will get an x value as how much? You will get an x value as how much? X value probably around 4.61%. So, there is a drop of around 4.61%. Okay. So, 50%, 4.615% of 50, you will get some the frequency loss. Okay. Out of that you can, this can be subtracted from 50. So, you will get the system frequency. Definitely it is less than 50 only, right. It should not be more than 50, right. Not even 50 also. More than 50 not possible, not even 50 also possible. Okay. So, if you solve that 4.61% of 50 and subtract from 50. So, you will get it down, you will get around 47.7 hertz. Okay. Whenever you are putting some load, definitely the speed falls and hence the frequency falls. So, it will not be 50 and it is not even more than 51 also, more than 50 also. You can eliminate two options and you can go ahead with the corresponding answers. Look at this one. A 1500 kilowatt 600 volts 16 pole separately excited generator runs at 200 rpm and has 2500 lap connected conductors and full load copper losses are 25 kilowatts. The generator is feeding full load of 1500 kilowatts at the terminal voltage of 600 volts. The area of the pole shoe, if the average flux density is 0.85 Tesla is. Okay. From the flux density I can say flux per area, right. Area of the pole shoe is asking, A is asking. So, which means flux divided by flux density. Flux density I have to calculate flux. Okay. 0.85 flux density Tesla I need to calculate this phi. How do you calculate this phi? He has mentioned separately excited generator, whether it is separately excited generator, shunt excited generator, let it be any kind of generator. Generally, EMF equation can be taken as pi p n by 60 times Z by A. From this equation I can calculate phi. Okay. So, here phi is unknown, number of poles how many, as it is lap connected, a lap connected means number of parallel paths equals to number of poles. So, poles, paths, number of parallel paths can be cancelled. Now, what is the speed he has mentioned? What is the speed he has mentioned? Did he mention any speed? Yes, he has mentioned speed as 200. So, let me substitute that 200 divided by 60 into total number of conductors Z value 2500 also he has mentioned. Now, if you can calculate E, then you can calculate phi. How do you calculate E? How do you calculate E? As it is separately excited generator, let me take up this field winding in a separate manner. The equivalent circuit I am drawing. As it is generator, I am writing it as EG and it is my load. Okay. I want to calculate this EG. To calculate this EG, terminal voltage plus drop is equals to EG, na? Yes or no? Terminal voltage plus drop is equals to EG, na? What is the terminal voltage, do you know? What is the terminal voltage, do you know? It is 600. It is 600. Okay. So, it is a 600 separately excited generator, runs at 200 rpm, has 2500 conductors and full load copper losses of 25 kilowatts. The generator is feeding full load of 1500 kilowatts at the terminal voltage of 600 volts. Terminal voltage is 600, load of 1500 kilowatts. So, PL is 1500 kilowatts. What is the terminal voltage? 600 volts. Now, can't you calculate the load current here? Can't you calculate the load current? This generator is going to deliver armature current, which is also nothing but load current. So, load current can be 1500 kilowatts divided by 600. Okay, divided by 600. You will get some 15 by 6 times 1000. Like this. So, this is around can solve the load current. You may get it this as okay, okay, probably 2500, I think so. Probably 2500 the armature current or load current. If you solve it, 2500, I think so. So, this is my armature current. If you get an armature current, is it possible to solve the generated EMF? No. You need to solve this armature resistance also. How do you calculate armature resistance? How do you calculate armature resistance? In between here, he has mentioned the copper losses. Full load copper losses as 25 kilowatts. If full load copper losses as 25 kilowatts, I can write this as IA square into RA is equals to 25,000. 25 kilowatts na. So, from here I can calculate RA. 25,000 divided by this IA square. How much is IA? I have got it as around 2500. So, 2500 square. So, you will get it as very small value, less than 1 ohm. It will be around 4 milli ohms. It will be around 4 milli ohms. So, I have got 4 milli ohms. Now, you can calculate EG. EG is equals to 600 plus IA is 2500 into RA is 4 milli. So, if you solve, probably you will get more than 600 na. 600 plus drop is equals to this EG. EG should be more than 600. So, if you solve it, you will get this as around 610 volts. So, I have got EG. So, you can substitute here 610. Now, once you get the EG, now solve for phi. If you solve for phi, you will get it as around 0.0732 Webers. Once you get this, you substitute in this equation. So, I will get area as 0.0732 divided by 0.85. You get it as area under the pole shoe, you get it as 861 centimeter square. If you solve it, 861 centimeter square you will get. Okay. All right. Let us see one more question. A 25 kVA 2000 by 200 volts 50 Hz transformer has maximum efficiency at 80% of full load. Loading he has mentioned 80% of full load. It is not a maximum efficiency, not 80%. Okay. Its per unit resistance and per unit impedances are per unit resistance and per unit impedances are 0.012 and 0.05 respectively. Its efficiency at half load or half of the full load and at 0.8 power factor lagging is. Okay. You want efficiency at half of the load, right? Half of the full load and 0.8 lagging. Efficiency formula will be X times kVA rating into power factor divided by output plus losses. So X I am writing the percentage loading at what loading is asking? Half of the full load. So 0.5 into kVA rating I am taking in terms of per unit value only, because the resistance and reactance in terms of per unit value. So I am taking in per unit value. kVA rating I am taking it as 1 per unit into at what power factor is asking? 0.8. So it is like X into E to I2 into power factor, X into kVA rating into power factor, output. Yes or no? Now output divided by output plus losses, 0.5 into 1 into 0.8, output plus losses. What kind of losses you want? Iron losses and copper losses. So put here iron losses and copper losses 0.5 square times full load copper losses. 0.5 square times full load copper losses. Now you need to solve full load copper losses and iron losses. Here remember, percentage resistance per unit resistance directly gives you full load copper losses. So here full load copper losses value can be replaced with 0.012 per unit. Now if you can calculate the iron losses, you will get the answer. If you can calculate the iron losses, you will get the answer. How do you solve for iron losses? I have an information, percentage X information, no. So the percentage X can be taken as, the percentage load can be taken as, during maximum efficiency, the percentage loading can be taken as root of Wi by full load copper losses. Yes or no? So how much is the percentage loading? 80%. So let me take up it as 0.8. Root, send out to the left side, it will be 0.8 square. Full load copper losses is equals to iron losses. Okay. So what is full load copper losses? We have got it as 0.012, that is equivalent to per unit resistance. So if you solve this, you will get the iron losses. So what is this iron loss you are going to get? The iron loss you are going to get it as around 0.00768. So once you get this iron losses information, you substitute here 0.00768 and solve for it, you will get around 97.39%. So approximately 97.4%. C could be the answer. Okay, right. People will do like this also, like, you know, as he has mentioned maximum efficiency, they use a formula like this, maximum efficiency and 80% of full load. So they do with 0.8 times 1 into power factor, they take up maximum efficiency now. So they'll go with 1 divided by 0.8 times 1 into 1 plus maximum efficiency, no, it is 2 times Wi. Total losses they'll take up as 2 times Wi. They'll try to solve for Wi, but they don't know efficiency. They'll stuck up here. Okay, don't do this. It is a load, percentage load corresponding to maximum efficiency. So use this one. Okay. Right. Let's see another one. A 10 HP, 550 volts, 50 Hertz, 3-phase delta connected induction motor has a starting current of 425% of full load current. What should be the voltage in order that the starting current can be limited to the full load value? You have to put a starter. Okay, without starter it is drawing 425% of the full load current. With starter, he is expecting to limit the value to full load current only. So generally, current is proportional to voltage, na? So if you reduce the voltage by X percentage, the current also reduces by X percentage. My starting current is around 425% of full load current, but I want that for current as equal to full load current. Now what amount of voltage you need to apply? It is just like voltage reducing method only, voltage control technique only. So starting current 2 divided by starting current 1 is equals to voltage applied in the second case to the voltage applied in the first case. So starting current in the second case will be voltage applied in the second case, that is what you need to calculate. Now starting current in the second case, how much he is expecting? Full load current only. Starting current in the first case it is 425%, so 4.25 times full load current. V2 you need to calculate. V1, let me substitute directly line voltage 550. So V2 you will get 550 divided by 4.25. So definitely it is not even 4 ones, 4 3s 12, 4 4s, 4 3s, maybe 130 nearby like that. If you solve it, probably you will get it as 121 or 129, maybe 129.21. So this is the voltage you can expect roughly. Because I am dividing with 4, you might be getting with 4 ones, 4 3s 12 like that, but 0.25 is also there, so you will get less than 130. It should be less than 130. So I can eliminate A and D also. Okay, less than 130 or near to 130. Okay, done. Calculator is allowed, no? So you can do that. Let's see this question. What is the increase in the torque expressed as percentage of initial torque if the current drawn by the DC series motor is increased from 10 amperes to 12 amperes? Neglect saturation. Neglect saturation. Is asking about torque. Torque is equals to K phi Ia. Let us keep this K motor constant aside. He has mentioned neglect saturation. Neglect saturation means flux is continuously linear. Flux changes continuously linearly with respect to current. So this flux can be replaced with armature current. Now I will be getting this torque as armature current square. Why I am writing flux is proportional to armature current? Because series field winding, na. So the series field winding is connected in series with the field winding is connected in series with the armature. Whatever the current carried by the armature, the same current flows through the field winding. So you can write phi with Ia. So my current is changing from 10 amperes to 12 amperes. Okay. So for 10 amperes 10 square it will be, let me take up it as 100. For 12 square it will be how much? 144, na? 12 square is 144. Now is asking what is the percentage, what is the increase in torque expression, torque expressed as in as percentage of initial value. With respect to initial value, what is the change? So the percentage change, how much you will get? 144 minus 100 divided by 100, 44%. 12 square is 144, so it's 1.44, so this is 44%. Okay. Look at this one. A transformer has primary winding of 800 turns and secondary of 200 turns. When the load current on the secondary is 80 amperes at a power factor of 0.8 lagging, the primary current is 25 amperes at a power factor of 0.707, of course lagging. The no load current of the transformer is dash. Okay. So, is asking no load current, I naught is asking. What is actually total current? Total current can be taken as no load current plus load component of current. Na? Right. This load component of current is nothing but K times I2. Load component of current is nothing but on the source side is nothing but K times I2. So, he is asking I naught can be taken as I1 minus K times I2. What is I1 primary current? What is I1 primary current? The primary current he has mentioned it as 25 amperes at 0.707. 0.707 is nothing but 1 by root 2. When will you get 1 by root 2? When the power factor angle is 45. So, I can say I1 is equals to 25 amperes lagging power factor, na? So minus 45 degrees. This is a power factor angle. 25 at an angle minus 45 amps. What about I2? I2 we have got it as secondary current as 80, but I want I1 dash K times. So it is K times I2. K is transformation ratio. Secondary by primary, 200 by 800. You will get it as 1 by 4, 200 by 800 times I2. What is I2? 80. At what power factor angle? At what power factor? 0.8 lagging. 0.8 lagging will be minus 36.86. Now you need to subtract these components. So 25 cos phi minus j 25 sin phi. It is like cos phi plus j sin phi format. 25 cos phi will be 0.707 minus j sin 45 will be 0.707. Okay, that is my I1. Next, k times I2. How much is that? 1 by 4. 1 by 4 times 80. You will get it as 20. 20. Cos of 36.86, 0.8. Sin of 36.86, 0.6. So, minus j 0.6. You expand this, you will get real terms, you will get imaginary terms, solve them according to the sign, subtract real terms, subtract imaginary terms, you will end up with x plus iy or x minus iy format. What do we want? We want no load current. This is no load current only, na? So you can take up the no load current magnitude. X square plus y square. Probably if you solve it, I think 5.92 something you are going to get. 5.92 because virtual calculator is allowed, na? So you just multiply the real terms, the real quantities, you will get real terms, imaginary terms. One real term, one imaginary term will be there. Then you can, it is easy for magnitude calculation. So that's the reason why I have given this one. Okay.
Hello everybody, welcome back. The next subject that we are going to discuss in the BARC mark is power systems, right? So this is the first question. A short transmission line having its line impedance angle as 30 degrees, impedance angle is given 30 degrees. For getting 0 voltage regulation, so right, the regulation should be 0, the receiving end lagging power factor angle should be, what is the power factor angle they are asking? Right students, actually we don't know, we know that the percentage voltage regulation, right, the condition for 0 voltage regulation is nothing but impedance angle plus power factor angle should be equivalent to 90 degrees, right. So impedance angle is theta plus power factor angle is phi r, so must be equivalent to 90 degrees, where phi r is equivalent to 90 minus theta, right. So what is the theta given? 30, it is 90 minus 30, that is the impedance angle, it will be 60 degrees is the answer, right. So option B is the perfect answer. That is the first question, right. Now we will go for the next question here. A 10 kilometers transmission line is operating at a frequency of 1000 hertz, right. So they have given the frequency 1000 hertz, then the transmission line will be, actually students, for a 50 hertz frequency, whenever the line length is 10 kilometers, we can say the line, the transmission line is short transmission line. But whenever the frequency of the system increases, right, automatically we have to shift our transmission line to long transmission line. Why? Because the charging current in the line will be increasing, right students. Therefore, definitely it will be the long transmission line, right. So whenever frequency increases, as a result, the charging current increases. So because of that one, so the capacitance we have to consider in the system, that's why the line should be the long transmission line, right. So next question, a string insulator has 5 units, the voltage across the bottommost unit is 35%, then the string efficiency is, so what is the percentage string efficiency? The percentage string efficiency is equivalent to total voltage across the string divided by number of discs n into voltage across the bottommost disc Vn into 100. So it will be V total divided by number of discs are 5 into voltage across the bottommost disc is 0.35 of the total voltage into 100. So V total will be cancelled here. It is 100 divided by 5 into 0.35, right. So if you calculate this one, you will get nearly 57.14%. 57.14%, right. So option A is the perfect answer. right. The next question, a system of 66 kilovolts, the line to ground capacitance is given 0.02 microfarads and inductance is 4 Henry. Inductance value is 4 Henry. When the magnetizing current is 8 amperes, find the voltage appearing across the circuit breaker contacts. Right. So, we know that the prospective voltage that appears across the circuit breaker contacts, V is equivalent to I root L by C, where I is 8 amperes, root of L is 4 Henry and C is 0.02 into 10 power minus 6. That is the value, right. So, if you calculate this one, we will get 113.13 kilovolts, right. So, option A is the perfect answer, right students. That is the next question. And if you see the next question here, the zero sequence network of a 3-phase transformer as shown in the figure, the corresponding transformer connection will be. So, we know that for a transformer, here we are having one switch, this is the transformer impedance, this is one more switch, like this we are having. So, the series switches should be closed for star connection, the shunt switches should be closed for the delta connection. Here it is given that it is closed and it is closed, so that it should be delta connection, it is also delta connection, the transformer connection should be delta connection, right. And the next question here it is, a 132 kilovolts 3-phase system circuit breaker has natural frequency of 20 kilohertz. So, frequency is given in hertz during a fault. Calculate the time taken to reach the peak value of restriking voltage. So, we know that the peak value of restriking voltage omega T naught, it will occur at pi, right. The time will be T naught is equivalent to, in place of omega we can write 2 pi f, we can write it is pi by 2 pi f. So, pi will be cancelled, it is 1 by 2 f. So, substitute the value of f, it will be 1 by 2 into 20 into 10 power 3. So, if you calculate this one, you will get 0.25 milliseconds, 0.025 milliseconds. So, option D is the perfect answer, right. And the next question, a short circuit test on a 66 kilovolts 3-phase system, the breaker gave the following results. The power factor is 0.5 and the recovery voltage is 0.9 of full line voltage. Then calculate active recovery voltage. So, we know that the active recovery voltage ARV is equivalent to some constant K1, K2 into Vm sin phi, where K1 is given 0.9 and there is no information about K2, we can take it as LG fault, we can take it as 1. So, Vm, the 3-phase voltage is given where Vrms is line RMS, line voltage is 66 kilovolts, phase voltage will be 66 kilovolts divided by root 3 into peak value will be into root multiplied with sin phi. So, where cos phi is given 0.5, sin phi will be root 3 by 2, root 3 by 2. So, this will be root of 3 by 2. Right, root 3 will be cancelled, and if you do the calculation, you will get approximately 42 kilovolts. 42 kilovolts is the answer. Option B is the perfect answer, students. Right, and we will go for the next question here. If the percentage reactance of the system up to the fault point is 40% and base MVA is 25, then short circuit, right, capacity in kVA. What is the short circuit capacity in kVA? Given is MVA and now they are asking in kVA. So, we know that MVA SC is equivalent to MVA base divided by X per unit, where MVA base is 25 MVA divided by X per unit is 0.4. We will get this as 62.5 MVA. But they are asking in kVA, it is 62500 kVA, right, 62500 kVA is the answer, right students. Now, see the next question here. A 3-phase 20 MVA 11 kilovolts alternator has internal reactance of 6% and negligible resistance. calculate external percentage reactance per phase to be connected in series with the alternator so that the studies current on short circuit does not exceed 10 times that of the full load current. Students, in this case, under short circuit condition, the steady state current should not exceed 10 times that of the full load current. So, we can say that ISC is equivalent to I base. Actually, ISC is equivalent to I base divided by X per unit. Right? In place of ISC, if you are writing V base here, if you are multiplying V base here, it will become MVASC. MVASC is equivalent to MVA base divided by X per unit. That is the formula we are having. Now, what they are saying that this MVASC should not exceed 10 times that of the full load value. Full load value means base value, right? What they are saying that this MVASC must be equivalent to 10 times of MVA base. MVA base. Where MVASC is MVA base divided by X per unit. It is MVA base divided by X per unit must be equivalent to 10 times of MVA base. So, we can cancel out MVA base where X per unit that you have to maintain is 1 by 10, it is 0.1 per unit, 0.1 per unit, which is nothing but 10%. 10, total of 10% if you have to maintain, but already existed is 6%, already existed is 6%, so that how much extra you have to maintain? 4%, right? So, that extra reactance that you have to maintain is 4%, right? 4% should be the answer. Already existed is 6%. Total you have to maintain is 10%. Right. So, next question is, a 3-phase induction motor is connected to a supply of 400 volts, 50 Hz. Its power factor is 0.6, lagging. A delta connected capacitor bank is connected across it to improve the power factor to 0.8 lag. The rating of induction machine is 4.5 kVA. The value of capacitance per phase. Right, we know that to calculate capacitance per phase, C phase is nothing but QCSH per phase value divided by omega into V phase square, where QCSH per phase is P by 3 into tan phi 1 minus tan phi 2 whole divided by omega into, omega means 2 pi f into V phase square. Substitute the values. P is nothing but S into cos phi. S is given here for 4.5 kVA. Therefore, C phase is nothing but S is 4.5 into 10 power 3 into 0.6 S into cos phi divided by 3. That is the per phase value into tan phi 1. So, cos phi is 0.6. Its related to tan phi is 1.33 minus tan phi is 0.8. Its related to cos phi is 0.75 whole divided by 2 pi into 50 into V phase. It's a delta connected capacitor bank where the phase voltage is same, right? As the line voltage, it is 400 square. So, if you do the calculation, you will get approximately 10.4 microfarad. 10.4 microfarad is the answer. Right. The next question, what will be the reserve capacity of a power plant having maximum demand of 100 megawatt? Given plant capacity factor is 0.45 and utilization factor of 0.8. So, you can directly write the utilization factor is nothing but maximum demand divided by plant capacity, where maximum demand is given 100 and we do not know the plant capacity, and utilization factor is given 0.8. So, where plant capacity is nothing but 100 divided by 0.8, which is nothing but 125 megawatt. Therefore, reserve capacity is nothing but plant capacity minus maximum demand. It is 125 minus 100, it will be 25 megawatt is the answer. So, 25 megawatt is the answer. Alright students. And the next question, the operating cost of 2 generating units operating on economic dispatch are given, right? So cost 1 and cost 2 are given, where P1 and P2 are in megawatt. The total operating cost to a supply load of 1000 megawatt is. So C1 is given, we can calculate IC1. What is IC1? Differentiation of this one. It will be 10 plus 16 into 10 power minus 3 P1, where IC2 is equivalent to 8 plus 18 into 10 power minus 3 P2. So we know that for economic load dispatch, these two should be same. IC1 should be is equivalent to IC2 should be is equivalent to lambda, where IC1 is 10 plus 16 into 10 power minus 3 P1 must be equivalent to 8 plus 18 into 10 power minus 3 P2. So you can send this one here, it will be 16 into 10 power minus 3 P1 minus 18 into 10 power minus 3, 10 power minus 3 P2 must be equivalent to 8 minus 10, it is minus 2. Let it be equation number 1. And one more equation you can write, P1 plus P2, that is the total load must be equivalent to 1000. P1 plus P2 must be equivalent to 1000 megawatt. So that is the second equation. Solve equations 1 and 2 and you will get the values of P1 and P2. So you can get the value of P1 is equivalent to 470.58 megawatt and P2 is equivalent to 529.42 megawatt. So these are the two values of P1 and P2. And substitute these two P1 and P2 values in this equation, right? So the total cost C total is nothing but C1 plus C2, where C1 is nothing but 10 P1. So 10 into P1 cost, it is 470.58 plus 8 into 10 power minus 3 P1 square, that is 470.58 square, plus C2 values 8 into P2 529.42 plus 9 into 10 power minus 3 529.42 whole square. So if you do this calculation, you will get 13235 rupees per hour. That is the overall cost we are going to get. Right, students? That is the next question. So on the next question, here we are having a 3-phase synchronous generator with 1 per unit terminal voltage supplying 50% of the total power, right? So actually it should be the peak power. It should be the peak power. So it is supplying 50% of the peak power it is able to deliver initially. The receiving end voltage is also maintained at 1 per unit. The equivalent reactance between sending end and receiving end before the fault, during the fault and after the fault are 1.5 and 1.732 per unit respectively. The maximum possible load angle of, if a 3-phase symmetrical fault at the middle of the reactance is. So actually we know that they are asking delta max value, where delta max is nothing but 180 degrees minus sine inverse of Ps by P max 3. But initially it is delivering P1. We can write initial power is nothing but the mechanical power, which is 0.5 times of PM1. It is 0.5 times of PM1 is nothing but EV divided by X1 equivalent, where X1 equivalent value is given, E and V also given, 0.5 into E is given 1, V is given 1, X1 equivalent is also given 1, so that it is 0.5. So that we got the value of PS1, PS or PE1. So we can write the value of PS and PM3 value. So what is the value of PM3? PM3 is nothing but EV divided by X3 equivalent, where E is 1, V is 1, E is 1, V is also 1 and X3 equivalent, it is 1.73. So 1 by 1.73, it is 0.577, right? Substitute that value here, it is 180 degrees minus sine inverse of 0.5 divided by 0.577, right? So approximately this will be 60 degrees, 180 minus 60, we are going to get nearly 120 degrees is the answer. 120 degrees is the approximate answer, students, right? So these are the questions we are having from the power systems, right students?
Electronic measurements and instrumentation subject questions, solutions I am going to discuss. Nothing but solutions of the measurement questions which are given in the mock test 1 I am going to discuss now. This subject name is generally called as measurements. This is also called as measurement. Nothing but it covers electrical measurements, electronic measurements as well as transducer part. But the subject title is this. Right? Now let us start the questions here. Here is the first question. A simple slide wire is used. Nothing but this is a question from slide wire DC potentiometer. And this is used for measurement of current. So he is measuring current. And the data is given like voltage drop across a standard resistor of 0.22 ohm is balanced at 75 centimeter. Nothing but 0.22 ohm. Resistance is 0.22 ohm. This is balanced at 75 centimeter. Nothing but 75 centimeter length related resistance is 0.2 he has given. After that, the magnitude of current is a dash. He is asking current. If the standard cell EMF, what is that? V standard cell is equal to 1.5 volt. This they want to balance it 50 centimeter. They want to balance it 50 centimeter. Under this condition, what is the current through the circuit? Now simple, 75 centimeter length is given. We need to find out 50 centimeter length correspondingly resistance. So simply 75 centimeter length resistance is given 0.2 ohm. In the same way, 50 centimeter how much? Why sir? 75 centimeter is balanced related to 0.2 ohm. So then our balancing should be at 50. Therefore, what is the resistance? Therefore, R is equal to 50 centimeter by 75 centimeter into 0.2 ohm. Right. If you simplify this, 25 to 25 3. So simply 0.4 ohm by 3. 0.4 by 3 ohm. Okay, this is the resistance. Okay, now simply I is equal to V by R. Sir, this is the length balanced with which voltage? 1.5. Therefore, 1.5 is the voltage by resistance 0.4 by 3 I am writing over here. Now what will be there? 4.5 by 0.4. Don't waste the time in this calculation. Simply 4 11s are 44, means approximately 11. So check it here. Only one option is there, directly 11.25. So answer you will be getting 11.25 amperes. Right? Next question. Which one of the following meter has minimum loading effect? Right? Under circuit, under measurement. The question is minimum loading effect. In it, what we can say, the device which should have high sensitivity. Check it here. 10 ohm for 1 volt means 1 volt has a 10 ohm, 1 volt has a 20 ohm, 1 volt has 100 ohm, 1 volt has 1000 ohm. So which is having more resistance? 1000 ohm for 1 volt only, but here 120 10. So automatically this is having high sensitivity, which implies here minimum loading effect. Right? Next question. The ballistic galvanometer, right? Damping follows. In the ballistic galvanometer, damping is of which type? So direct question, logarithmic function will be there. In the logarithmic notation, the corresponding damping will be following. So therefore, in the ballistic galvanometer, which type of damping follows which type of nature means logarithmic nature. Right? Next one. Which of the following types of instruments could be used to measure peak value? Guys, PMMC measures which value? Average value. CRO, V peak to peak, V peak, VRMS, time period, frequency, everything. And here V peak is there, okay. But peak value, maximum value is possible. And spear gap voltmeter also, yes, can read peak value. Therefore, what is the answer? Both B and C. Both are correct. Right? Next question. A resistance strain gauge. This is the question from transducers, that is resistive transducer. In that resistive transducer, strain gauge topic. Okay. With a gauge factor 4. So, what is the gauge factor they have given? Gauge factor is given as 4. And then fastened to a steel member subject to a stress of. So, stress is given. Stress means simply sigma, we can say. What is that? 100 Newton per mm square. The modulus of elasticity. Modulus of elasticity or Young's modulus. So, simply denoted with YRE. What is the value? 2 into 10 power 5 Newton per mm square. Newton per mm square. The percentage change in the resistance is dash. They are asking percentage change in the resistance. Percentage delta R by R is a dash. Now, very simple. So, gauge factor is given. For this question, we should be able to recollect the formula of gauge factor. What is the gauge factor formula? Gauge factor is equal to delta R by R by strain. Delta R by R by strain. Guys, what is the strain formula? What is the strain formula? Strain epsilon is equal to stress by Young's modulus. Why, sir? The Young's modulus is equal to, Young's modulus formula is stress by strain. This is a general formula we know. Stress by strain. Now, what we require? Strain we require. Therefore, stress by Young's modulus. That will be written stress by Young's modulus. What is stress? Stress is given as 100 by Young's modulus 2 into 10 power 5. Guys, both are having same unit, no need to mention. And the 2, the strain is of no unit. Delta L by L, change in length by original length is the formula of strain. So, definitely no unit. And here, what will be there? 50 into 10 power minus 5. This is a strain. Don't write any unit because it is a unitless component. Now, therefore, gauge factor is equal to delta R by R by strain. What we require finally? Delta R by R. So, from this, what we can write now? Delta R by R is equal to gauge factor into strain. What is gauge factor value? 4 into. What is the strain value? 50 into 10 power minus 5. So, therefore, 200 into 10 power minus 5. This is also no unit. Why? Delta R by R, ohm by ohm, no unit. But don't wait and don't get confused with the options. Here, he is asking clearly, which one? Percentage change. But we got only delta R by R value form. Therefore, percentage delta R by R is equal to, percentage delta R by R is equal to, what is that? 200 into 10 power minus 5. Percentage is there? No. We need to multiply with 100. Now, what will be there? 2 zeros and 2 zeros, 4 zeros, and here 5 zeros are there. Therefore, 4 and 4 will be cancelled. 10 power minus 1 into 2 means directly 0.22%. 0.22%. So, this is the answer. So, these are the questions from the measurement subject. Clear?
Hello everyone. Let us discuss now questions from subject Power Electronics. EEE BARC Mock Test 1 Power Electronics. So, this is the first question. For an SCR, the gate cathode characteristic has a straight line slope of 130. Slope of the gate cathode characteristic given means Vg by Ig given. For trigger source voltage means here ES given of 15 volt and allowable gate power dissipation of 0.5 watt, maximum gate power dissipation given. Compute the gate source resistance, means the resistance connected in gate cathode circuit in order to limit the gate current. That resistance value we need to find here, means RES value we need to find. Okay, right. So our task is to find the value of RS, right, gate source resistance. Here first let us note the data. Slope given means Vg by Ig is equal to 130 given, right. From this I can write Vg equal to 130 Ig. Vg equal to 130 into Ig, right. Next it is given that gate source voltage ES is equal to 15 volt and gate power dissipation allowable means Pg max given, which is equal to 0.5 watt, right. Now we know Pg max is equal to Vg into Ig is equal to 0.5. Further replace that Vg with 130 Ig because Vg is 130 Ig na. So put this Vg here. So we can get it as 130 Ig into Ig is equal to 0.5. So from this 130 Ig square is equal to 0.5. Simplify this, we can get Ig. So Ig equal to 62 milliampere. This is my Ig. Now Ig we got, let us find Vg. Vg is 130 Ig na. So put that Ig here, you will get Vg. So Vg equal to 130 Ig, which is equal to 130 into Ig is 62 milliampere. 62 milli means 0.062 ampere. Simplify this, you will get it as 8.06 volt. This is Vg. Now RES is equal to ES minus Vg upon Ig. So ES given is 15 volt minus Vg is 8.06 upon Ig. Ig is 62 milliampere, right. 62 milli means 0.062 ampere. Simplify this, you will get it as 111.9 ohm, right. 111.9 ohm. This is my RES, right. 111.9 ohm. So correct answer is option C. All right. Yeah. Next, a type A chopper has input DC voltage of 200 volt and a load of resistance 10 ohm in series with a L 80 millihenry. Load is RL load. Type A chopper given, supply voltage given 200. If load current varies linearly between 12 ampere and 16 ampere, load is RL load and load current given, means can I say that load current is nothing but same as that of the current flowing through the inductor. So here I min I max given 12 ampere 16 ampere. Find the time ratio T on by T off for this chopper. Our task is to find the T on by T off. Okay. So here we can write let us write IL mean or simply write I min and I max. IL mean equal to 12 ampere, IL max is equal to 16 ampere, right, 16 ampere. So what is IL average? We know IL average is equal to IL mean, that is I mean plus IL max means I max upon 2 na, which is equal to 12 plus 16 by 2. That is equal to 14 ampere. This is IL average, which is again same as that of I0 average na, because load is RL, means inductor current is same as that of your load current. So I0 average is equal to IL average is equal to 14 ampere. Now what is V0 average? V0 average is equal to I0 average into load resistor R. Average voltage across inductor is 0. So therefore average load voltage is nothing but average voltage across only resistor. So I0 average into R. I0 average is 14 and R value given 10. So you can get it as a 140 volt. This is my V0 average. Now here type A chopper. Type A chopper is nothing but simply your step down chopper. We know in case of step down chopper, V0 average is D into Vs. V0 average is equal to D into Vs. So it is 140 is equal to D into Vs is 200. So from this we can get D equal to 0.7. So duty cycle is 0.7. Now here they are asking T on by T off ratio. Now T on means on time of the chopper and T off is a off time of a chopper. Can I write T on is nothing but dt, capital D into capital T, and T off is 1 minus D into T. So here T cancel out. So it is simply D upon 1 minus D. So what is the D? D is 0.7 upon 1 minus 0.7. So it is equal to 0.7 upon 0.3. If you take 0.7 by 0.3, you will get it as 2.33. 2.33, right? So final answer is a 2.33. So if you check the options, option B is the correct option. All right? Yeah. Next, a single phase diode bridge rectifier is feeding a parallel combination of R load and a capacitor of high value. Here, diode bridge rectifier given means full wave rectifier. Load is a purely resistive, but across load a capacitor is connected. You can say capacitive filter is connected. Capacitor is connected. The nature of input current drawn. Input current means source current by the rectifier from AC source is. So here they are asking what is the nature of the source current. If you check for this circuit, if capacitor is connected across the load, my capacitor will try to maintain the load voltage to some value, right? To some constant value. So as and when my supply voltage becomes greater than the output voltage, then and only then your load current, then and only then your source current will flow. So here you will be getting the nature is a peaky wave with peaks at a positive half cycle as well as a negative half cycle. Sorry, peaky wave, option C is the correct option. Peaky with peaks at both positive and negative half cycle of the input voltage. Here diode bridge rectifier means you are having this type of circuit. Capacitor is connected and here it is a load supply. They are asking nature of the source current IS. Because of capacitor, what will happen? If you check first without capacitor, how will be my output voltage waveform? Without capacitor, my output voltage waveform will be normal, that is a pulsating. This type of waveform, right? But here high value of capacitor is connected. So in a continuous cycle operation, if I neglect charging discharging of a capacitor, because capacitor value is high means capacitor opposes the sudden change in voltage, means my capacitor will maintain voltage here as a constant. So I will be getting some constant waveform across the load V0, this much voltage. So here voltage is V0, here voltage means here voltage. So what happens as and when during positive half cycle of supply, as and when Vs value becomes greater than V0, then and only then these two diodes will conduct, and so your current will flow. So your current will be having the peaky nature, means like this. As and when supply voltage is greater than the load voltage, then and only then the current will flow. So you'll be getting this type of some peaky nature waveform. When Vs is greater than V0, right? Again from this point to this point, no conduction of diodes. Again from this point to this point, you will be getting a negative peak in output. So you'll be getting a peaky waveform in a output, peaky waveform, right? Yes. So your answer will be option C, positive as well as negative cycle peak you will be getting, right? Yeah. Yeah. Next question. In the circuit in figure, L is 5 microhenry and capacity is 20 microfarad. Capacity is initially charged to 200 volt. After the switch S is closed at t equal to 0, the maximum value of the current and the time at which it reaches this value are respectively. Means here they are asking what is the peak value of the current and at what time the current will reach to the peak value. Check this circuit. Here capacitor is initially charged to 200 volt na. So here charged capacitor and only inductor is present. This is your tank circuit. When you connect a charged capacitor across the inductor, what is the expression for current in a circuit? I equal to Vs under root C by L sine of omega 0 t na. What is omega 0? Where omega 0 equal to 1 by root LC, right? 1 by root LC. So what is the peak value of current? Vs under root C by L. So let us write I peak is equal to Vs under root C by L, which is equal to Vs is voltage across capacitor under root C by L. C is 20 microfarad and 5 microhenry. 20 micro upon 5 micro. Vs under root C by L, right? Simplify this, you will get it as a 400 ampere. This is I peak. And what value of time this current value reach? This current will reach to this value. Check in tank circuit analysis, we are having current nature is this type. This time is pi by omega 0. This is t. So peak value will be at pi by 2 omega 0, right? Pi by 2 omega 0. So time at which current reaches peak value, that time is pi by 2 omega 0. Omega 0 is 1 by root LC. Put here. If you put 1 by root LC, you will get it as pi root LC by 2, right? Pi root LC by 2. So it is pi into under root 20 into 10 to the power minus 6 into 5 into 10 to the power minus 6 upon 2, right? Simplify this, you will get it as a 15.707 microsecond, right? Yes. So 400 ampere and 15.707. Option C, A is the correct option, right? Yeah. Next. In the circuit shown in figure, SR is forced commutated. Compute the minimum value of capacitor so that SR does not get turned on due to reapplied dV by dt. First, SR is in a conduction mode. Now it is turned off due to forced commutation. SR is turned off by using forced commutation. Okay. And again, once it forced commutated, then we need to find the value of C here required in order to avoid the false triggering of this SCR. The SCR has minimum charging current of 5 milliampere to turn it on. Means when current flows through the SCR is a 5 milliampere, then SCR will turn on. And its junction capacitance is 25 picofarad. C is a given 25 picofarad. Okay. So let us simplify this. Our task is to find the value of this capacitor C. So first is when SR is in a conduction mode, right? Let me write here voltage across thyristor is VT and voltage across capacitor is VC. Okay. When SR is in a conduction mode means it is acting as a short circuit na. It is acting as a short circuit means VT and VC both will be 0, right? When SCR is in a on state, VT equal to VC equal to 0 means initial capacitor voltage is 0. Now when SR is turned off due to force commutation, when SCR turn off by using the force commutation, it is turned off means SCR will act as an open circuit na. SCR when it acts as an open circuit, can I say that my current will flow like this, Vs, R, C and again back to the Vs na. So it is like DC voltage source connected across RC branch. What is the expression for voltage across capacitor? When DC voltage source is connected across RC branch, the expression for voltage across capacitor Vc, which is again same as that of Vt. Okay, so I can write here Vc is equal to Vt equal to Vs into 1 minus e to the power minus t by tau, that is e to the power minus t by tau. Tau is a RC. When DC voltage source is connected across RC branch, we are having the standard expression for voltage across capacitor, right? This is Vc and Vt. Now differentiate this with respect to time. Differentiate with respect to time. If I differentiate it, I will be getting it as dVt by dt, or you can write dVc by dt also, doesn't matter. Yes, differentiation of this term is Vs into 0 minus of e to the power minus t by Rc into minus 1 by Rc, right? So minus minus will become plus, so we can get it as Vs by Rc into e to the power minus t by Rc. This is a dVt by dt, right? Now as time increases, this term decreases na. So can I say that this dVt by dt will be maximum when t equal to 0, right? At t equal to 0, at t equal to 0, dVt by dt is a maximum. Is a maximum. So I can write here maximum dVt by dt is equal to Vs by Rc na, Vs by Rc, because it at t equal to 0 means e to the power 0, e to the power 0 is 1, so we will be getting maximum dVt by dt is a Vs by Rc. So this is the maximum dVt by dt, that is maximum du by dt appearing across the thyristor is this value. Now we need to find the value of the capacitor required here in order to avoid the false triggering of the thyristor. Recall in chapter number 1, when because of we are protecting the SCR against the high du by dt. Because of high du by dt, my SCR may false trigger na, and in order to save the SCR against the false triggering, actually we are using snubber circuit, RC snubber. But here in this question, that resistor they have not given, only they have given the capacitor. Anyways, capacitor function is to limit the du by dt na, right? Yeah. So here maximum dV by dt is a Vs by Rc, is a Vs by Rc. Now here I can write Vt and Vc both are same na. So I can write current flowing through the thyristor. Thyristor is behaving, a thyristor junction capacitor given na. So this thyristor is behaving like a capacitor now. When thyristor is in off state, it behave like a capacitor because across the junction we are having the formation of depletion layer. So your thyristor is behaving like a capacitor. So thyristor junction capacitor given. We know in case of capacitor, I is equal to C into dV by dt na. Yes, so here I can write current flowing through thyristor IT equal to Cj into dVt by dt. Now current flowing through thyristor is nothing but here 5 milliampere given, right? Now further I can write this current will be maximum when dVt by dt is maximum. So maximum IT is equal to Cj into maximum dVt by dt. right? Now maximum IT is 5 milliampere. 5 milli means 0.005 is equal to Cj given 25 picofarad into maximum dV by dt, that is Vs by Rc. Vs by Rc. Now put the value here, 0.005, 25 picofarad. Vs is 200. Vs is 200, yes. R is 50 into C. Right? Simplify this, you will get the value of capacitor, which is equal to 0.02 microfarad. Right? 0.02 microfarad. So if you check the options, option C is the correct option. Next question. Yeah. In an electronic device having total harmonic distortion 12%. So THD given means harmonics are present in your waveforms, and the output waveform V and I lag by 30 degree. Here phase relation between V and I given means phase relation between fundamental current and output voltage given, right? Let us consider my output voltage is pure sinusoidal and output current is a non-sinusoidal. If voltage is sinusoidal, current is non-sinusoidal, then for finding the power factor means input power factor, what we are doing? Yes, we know power factor or input power factor is equal to df into dpf, na? df into dpf. Now dpf they have given, it is a cos 30 degree, that will give you the dpf. We need to find the df. We need to find the df. For finding df, let us take the help of THD. What is THD? Percent THD is equal to under root I0 RMS square minus I01 RMS square upon I01 RMS into 100 into 100, na? So now from this I can write shift 100 to this side, then I will be getting it as 0.12. 12 by 100 means 0.12 is equal to, yes, this term I can write it as under root I0 RMS square upon I01 RMS square minus I01 RMS square upon I01 RMS square. Check. What I have done? This I01 RMS I have given in the square root, that will become I01 RMS square. So I0 RMS square upon I01 RMS square minus I01 RMS square upon this. So this will become 1, na? And what this I0 RMS square upon I01 RMS square? Can I say that this indicates my square of the distortion factor df. df means it is a ratio of 1 by df. df means df equal to I01 RMS upon I0 RMS, na? Distortion factor is this one. Now here we got I0 RMS upon I01 RMS square, means it is 1 by df square. So I can write here 0.12 is equal to under root 1 by df square minus 1, na? Right? So square both sides, 0.12 square is equal to 1 by df square minus 1, right? So therefore I can write it as 0.12 square means 0.144. Yeah, I think it is 0.0144. You can check it, which is equal to 1 by df square minus 1, na? Right? 1 by df square minus 1. So from this I can write df square is equal to, or 1 by df square is equal to 0.0144 minus 1. Okay. So from this we will get df square equal to 1 upon 0.0144 minus 1. Okay, right. Sorry, it is plus 1. That minus 1 will go that side, na? So that will become plus 1. Okay, you can simplify this, you can get df. Okay, so if you simplify this, you will get df equal to 0.9928. This is df. Now, what is input power factor? df into dpf. df is 0.9928 into dpf is 30 degree they have given, means cos 30 degree, right? So simplify this, you will get 0.8598, right? So here answer A is the correct option, right? Be careful here, THD given means harmonics are present, that you need to understand. And this angle is given, so it is angle between fundamental current and your voltage. Voltage is sinusoidal. One you should assume sinusoidal. Voltage sinusoidal, current non-sinusoidal, or current non-sinusoidal, current sinusoidal, voltage non-sinusoidal. Okay, right. So next, yeah, this is simple question. So they gave this circuit. Select the most suitable condition. So and condition given, I of t is always present. Is of t flows continuously. Is of t flow when S1 is on at E of t greater than 30, and A and C both options are correct. If you check in this circuit, yeah, when supply voltage Vs, let me write, when supply voltage is less than 30 volt, E of t, sorry, they have given it as E of t, so let us take it as E of t. Instead of Vs, let us take it as E of t. When this voltage is less than this value, what will happen? This S1, that is thyristor, will be in off state. Only diode will conduct and current will flow in this loop, na? So when E of t is less than 30 volt, then S1 off, diode D on, current I of t become non-zero, na? That is I of t will flow, only current will flow in this loop. And what is Is of t? 0. Is of t is 0. Similarly, tell me when E of t is greater than 30 volt, what will happen in circuit? When this voltage is greater than this value, means diode will become reverse bias, your diode will be in off state. This S1 will conduct and current will flow in outer loop, na? Right? So here when E of t is greater than 30 volt, S1 will conduct and diode D will be in off state. Here current will flow outer loop, means Is of t and I of t both are non-zero, na? Both are non-zero, right? So check, when E of t less than 30, then I of t is non-zero, and when E of t greater than 30, then also I of t is non-zero, na? So I of t non-zero means your I of t always present. Always present means it is always non-zero, it will always flow. What about Is of t? Whether Is of t flows continuously? No. Check, when E of t less than 30, Is of t is 0, means Is of t not flowing. Is of t flow only when E of t greater than 30. So option B is not correct. What about the third? Is of t flow when S1 is on at E of t greater than 30. Yes, same we have written. So A and C both are true, means option D is the correct option, right? Option D is the correct option. All right. Yeah, next. A single phase circuit for temperature regulation uses on-off control. Here temperature regulation circuit they are talking. The AC input is 400 volt, single phase 50 Hz supply. Input voltage is a 400 volt 50 Hz AC supply. The circuit has a variable frequency constant on time. Variable frequency constant on time, right? If the input voltage goes up by 15 degree, means supply voltage increase by 15 degree, calculate the percentage change required in the triggering frequency of chopper. Yeah, Here strictly speaking, for the chopper the input should be DC, and here they are talking about the AC. So here what is happening in this circuit, we are having a AC supply that we have given to the rectifier unit, and at the rectifier unit output side the capacitor is generally connected in practical case, so that my capacitor will maintain the constant voltage, and that rectifier will convert AC to DC, and that DC we are giving to the chopper, okay. Now here our task is to temperature regulation, means here I need to maintain the output voltage of the chopper constant. We want V0 constant, V0 as a constant. Now we know in case of chopper V0 is equal to D into Vs na. By default if they use the term chopper, means you need to take it as a step down chopper only, because step down chopper is a basic chopper circuit, right. So D into Vs. Now what is the D? D into T on by T into Vs. So can I write it as T on into F into Vs? 1 by T is a F na. So V0 is equal to T on into F into Vs, right. Now V0 is a T on into F into Vs, right, T on into F into Vs. Here on time, constant on time na, means T on we need to maintain constant, right. With some supply voltage and some frequency you will be getting the V0 value. But I want to maintain the V0 constant, even though my input voltage, that is Vs, will increase by 15%, means that should be again equal to T on is constant, frequency let us consider it as F dash, and now voltage, supply voltage is increased by 15%, means can I write it as 1.15 into Vs? Means supply voltage increased by 15%, then I need to vary the switching frequency in such a way that my output voltage should be maintained a constant. Here T on is constant, they have given, right, constant on time means T on is constant, okay. So therefore here T on will get cancelled out. I have written same T on both sides, but frequency is a variable frequency na, right. So control is variable frequency and constant on time. Now equate this, F into Vs is equal to F dash into 1.15 into Vs, right. So from this I can get Vs cancel out, F dash by F equal to 1 upon 1.15. This is my F dash upon F ratio. Now they are asking percentage change required in a triggering frequency. So percentage change in a frequency is equal to F dash minus F upon F into 100. So F dash is, sorry, this can be written as F dash by F minus F by F na into 100, alright. F dash by F is 1 upon 1.15 minus F by F is 1 into 100. Yes, we can simplify this and we can get the answer, alright. So if you simplify this, we will be getting it as minus 13.04%, right, minus 13.04. So here correct answer is option D, alright. So simply they have mentioned the temperature regulation on off circuit. From that you need to understand here chopper is given. Chopper given means my input to the chopper should be DC. So you need to recall how to convert AC to DC. So rectifier unit is used here, alright. And that this statement is important. Circuit has a variable frequency and constant on time, alright. Yeah. Next, yeah, for the isolated buck boost converter as shown in the circuit below. This is a buck boost converter, but only thing is here isolation is used. Output voltage is to be 50 volt. V0 we want constant 50 volt. This is V0, 50 volt, right, constant voltage. Yes, constant voltage. And yes, at a duty cycle of 40%. The DC input is obtained from a front end rectifier without voltage doubling fed from a 150 volt AC. Input to the rectifier is 150 volt AC, and here rectifier is used, the front end rectifier. Front end rectifier means like your normal rectifier circuit, but a filter is used, a capacitor is used here. What is the peak forward blocking voltage of switching element? So what is the peak forward blocking voltage, peak value of the blocking voltage of this element, they are asking. So for finding the peak value of the blocking voltage here, we require what will the voltage that will be appearing across this primary side of the transformer, right? Primary side of the transformer. Here turns ratio is not given. We need to find it. We need to find it. Okay. Here first thing is, this is the isolated type buck boost converter. So my output voltage expression for buck boost converter isolated type is A. A is nothing but it is a secondary side number of turns to the primary side number of turns of a transformer into D upon 1 minus D into Vs. Okay, right. So here V0 given is a 50 volt, which is A into D is a duty cycle 40%, 0.4 upon 1 minus 0.4 into Vs. Now Vs or V1 you can write, okay, V1 or Vs, right. Now here V1 or Vs here means input voltage to this chopper circuit, right. Here input is given to the chopper by using the rectifier. Output of the rectifier is given as an input to the chopper, and my rectifier here capacitor is connected across the load of a rectifier. So therefore I am going to get output voltage of the rectifier is nothing but a peak value of the input voltage, right, peak value of the input voltage. Input is 150, so peak will be 150 root 2. 150 root 2. Simplify this, you will get it as, you will get the value of the A, right. A is equal to 0.3535. That is nothing but number of turns at the secondary side upon number of turns at the primary side. So if we got number of turns at the secondary side upon number of turns at the primary side, so from that we can get the peak forward voltage, VSW peak voltage across the switch is equal to Vs plus A into what is the voltage at a transformer secondary side? Secondary side voltage is 50. A into 50. So it is a Vs is a 150 or 150 root 2 peak value they are asking, plus 0.3535 into 50, right. That should be V0 by A actually. Because it is secondary side to primary side, na? So primary side voltage yes, it is a V0 by A. V0 is 50 volt, so 50 by A. A is 0.3535, right. So we are having V secondary side voltage, V secondary upon V primary is Vp is equal to A, na? N2 by N1 means what? V2 by V1. So from this can I write my primary side voltage is equal to V secondary side voltage upon A. So that is nothing but V0 by A, right. This voltage is nothing but voltage across this, right. So therefore I have written it as V0 by A, not it is V0 into A, it is V0 by A, right. So now simplify this, we can get it as a 353 353.57 volt. 353.57 volt. All right. Yeah. Next question. Right. The turn on time of the SCR is 10 microsecond for the pure resistive load. Latching current is 60 milliampere given, IL given. Holding current is 45 milliampere. Is triggered by a short duration pulse and it is used in the circuit shown in figure. Minimum pulse width required. So they are asking TP to turn on the SCR. So check this circuit. Consider current here is I. SCR is connected only in RL branch na? SCR is connected in series with RL branch. Right? So here I need to maintain, check these type of questions were discussed multiple times. Minimum pulse width required. Alright. So for finding the TP, we require the time, we need to find the time required for this current to reach which value? Latching current value. Alright. So what happens here when SCR is in a conduction mode? When SCR turn on, then current flowing through the SCR is nothing but current flowing through the RL branch na? Across the RL branch you are having a direct DC voltage source. Only DC voltage source. So we can write current flowing through SCR. When SCR is in a on state, yes, we can write current flowing through SCR I equal to, it is 200, we supply voltage upon branch resistance, that is 10 into 1 minus e to the power minus RT by L, that is minus 10 into T by 1. Right? So it is I equal to 20 by 10 means 200 by 10 means 20 into 1 minus e to the power minus 10t. Right? From this, if you check my current nature in a SCR is like this. At t equal to 0, current will be 0. E to the power 0 is 1, 1 minus 1 is 0. As time increases, this term decreases. So this difference will go on increasing. So current will increase. And at t equal to infinity, my current will reach to the steady value. Alright. So I need to maintain the gate pulse till my SCR current reaches which value? Latching current. So suppose here your SCR is reaching to the latching value. So we need to maintain the gate pulse till SCR current reaches the latching current value. Now we need to find the value of this TP. How to find TP? Simply in this expression put at t equal to TP, I equal to IL. At t equal to TP, I equal to IL. Right? So it is IL equal to 20 into 1 minus e to the power minus 10 into TP. Now IL means latching current given 60 milliampere. 60 milli means 0.06 ampere is equal to 20 into 1 minus e to the power minus 10 into TP. Right? We can simplify this. Right? So after simplification we will get it as 300 microsecond. TP is 300 microsecond. Alright, 300 micro. Yes, so friends, the correct answer is option A. Option A is the correct answer. So these are the questions from subject of power electronics, right?
Which are related to the electromagnetic fields. Fine. So here is a question. If B is equal to B naught into e to the power of kt z cap for cylindrical region for rho less than B, then the electric field intensity E is fine. So he has given the magnetic field and is asking for the electric field. So electric and magnetic fields are related by what is called a Faraday's law. So there is a cylinder here. Cylinder is having a radius B, and is asking the radius of the cylinder is B, but is asking what is the electric field only for the radius rho. So here the magnetic field is changing with respect to the time. It will going to induce the electric field. So the electric field will be around the magnetic field. Fine. So you have to make use of the Faraday's law in the integral form, which is closed line integral of E dl, which is equal to minus surface integral of dou B by dou T into dA. Correct? So, this is closed line integral of E phi into dl, which is equal to minus surface integral of dou by dou T of B. What is the B here? It is B naught into e to the power of kt into z cap, dot product with the differential area. What is the differential area of this part? It is rho d phi z cap. Now, here you can bring this E phi outside. It is closed line integral of dl. You can perform the differentiation and bring the constant outside. Here it is B naught into k into e to the power of kt. Surface integral of it is z dot z is 1. So, it is rho d phi. So, this one is a perimeter. It is E phi into 2 pi rho, which is equal to minus B naught into k into e to the power of kt. Separate out the variables here. So, it is the integral rho into d rho into d phi. Clear, guys? So, it is E phi into 2 pi rho, which is minus B naught into k into e to the power of kt. Perform the integration. Here it is rho square by 2. Rho limits are obviously from 0 to rho. This is a cylinder. The phi limits will be from 0 to 2 pi. Yes, guys? Let me turn the page here. So, here E phi, perform the simplification here. There is a substitute upper limit minus lower limit. Here it is 2 pi rho, which is equal to minus B naught into k into e to the power of kt, correct? Okay, into it is rho square by 2 into 2 pi. You can just remove the 2 pi on both sides and the rho also. What is left here? So, the E phi is equal to minus B naught into k into e to the power of kt by 2, correct? Into rho. So, rearrange this one according to the options here. It is minus 1 by 2 into, check out the options here. So, there is a minus 1 by 2 B naught into k into rho into e to the power of kt. I will write this one in the vector form. So, the E vector is equal to minus 1 by 2 into B naught into k into rho into e to the power of kt into phi cap. Clear, guys? So, obviously option C is the answer. Yes, cross check, minus 1 by 2 into B naught into k into rho into e to the power of kt phi. So, the option C is the answer. Correct? Let us have one more question. So, here in this question, what is given is a charge enclosed by the volume. So, the rho r is ranging from 2 to 3. It is a spherical coordinate system and the volume charge is given. So, he is asking for the total charge. So, if the volume charge is given, how do you find out the total charge? We need to perform the volume integral, right? So, for the total charge, Q is equal to volume integral of rho v into dv. It is a spherical coordinate system, isn't it? So, just substitute the things and perform the integration. The rest of the story is just mathematics. Fine. So, what it is 4 cos square phi divided by r square. And what is this differential volume in the spherical coordinate system? It is r square sin theta dr d theta d phi. I will write one more step, bring the constant outside here. So, this is volume integral of cos square phi into sin theta dr d theta d phi. Separate out the variables here. So, the 4 into dr, here it is sin theta into d theta, and this is cos square phi into d phi, correct? Okay. So, perform the integration here. Let me write down one more step. It is 4 into r, it is dr, it is sin theta d theta into this cos square can be written, cos square phi can be written as 1 minus cos 2 phi divided by 2 into d phi, correct? Perform the integration. It is 4 r by 2. The r limits are from 2 to 3. So, it is minus cos theta. For the spherical coordinate system, the theta will be from 0 to 5. You must be careful with the theta. And this one, you can take this 1 by 2 outside. What is the integration of 1? It is a phi minus sin 2 phi by 2, where phi is ranging from 0 to 2 pi. Substitute upper limit minus lower limit. It is 4 into 3 minus 2 into minus minus 1 minus 0 into 1 by 2 into it is, this is 5 guys. So, it is 2 pi, and sin 2 pi into 2 pi, everything will be 0. So, check out this value, it is 4 into 1 into, this is 2 into pi, which is 8 pi. Yes, so the total charge enclosed within that sphere will be 8 pi coulombs. So, what is the answer? Option C is the answer. Clear guys? Let us have one more question. Here is a question, this is related to the boundary conditions. Consider the two current free regions, there is no surface current. Shown in the figure, he has given the B1, he is asking for the H2, right? So, he is asking for the H2. What I will do? So, this is in the question itself, it is mentioned that is a medium 1, medium 2, it is Z is equal to 0, in the sense it is the XY plane. So, Z is equal to 0, whichever is a constant, that itself is a normal, remaining are tangential components, fine. So, in the boundary condition problems, the very first thing is you need to identify the tangential and normal component, and correspondingly you need to apply, you need to run the boundary conditions over them, fine guys. So, here Z itself is a normal component, X and Y are the tangential components. The only thing is you need to recall the boundary condition formulas. So, we have a boundary conditions, Bn2 is unconditionally equal to Bn1. So, I can write this one in the vector form. So, which is equal to, what is the normal component in the medium 1? It is a phi z cap. Then how do you do the tangential component? There is no direct boundary condition. We have a boundary condition, Ht1 minus Ht2 is equal to Js. Here there is no surface current. That is what he has mentioned in the question. So, H2 is equal to Ht1. So, I will going to modify these things into the magnetic flux density. So, I will going to multiply and divide by the mu2 here. So, this is mu1. So, this is Bt2 by mu2 is equal to Bt1 by mu1. Clear guys? I will going to turn the page here. So, how I can write this one? It is Bt2 is equal to, go back, mu2 by mu1 into Bt1. I will going to turn this one into the vector. So, Bt2 vector is equal to mu2 by mu1 into Bt1 vector. So, what is this mu2 guys? The mu2 is, it is mu naught into 1 divided by, what is this mu naught into mu1? The mu1 is 3. And what is the tangential component here? The tangential component is this entire part, 2x cap plus 4y cap. It is 2x cap plus 4y cap. So, Bt2 is equal to 2 by 3 x cap plus 4 by 3 y cap. Then what is the overall vector? B2 is equal to Bt2, which is 2 by 3 x cap plus 4 by 3 y cap plus, what is the normal component here? Phi z cap. But this is not the question, he is asking for H2 vector, isn't it? So, what is the H2 guys? The B2 is equal to mu2 into H2. So, which is mu naught into, what is this mu R2? Mu R2 is 1, fine. So, this is H2. So, what is the H2? H2 is equal to 1 by mu naught into B2. So, H2 is equal to 1 by mu naught into 2 by 3 x cap plus 4 by 3 y cap plus phi z cap. This is the answer. Units are Weber per meter square, or simply one can say Tesla. Yes. So, what it is? You can check out. So, 2 by 3, 4 by 3, 2 by 3, 4 by 3 and then 5. So, option B, option A is the answer. Clear guys? Okay, here is a question. The energy density of the magnetic field in a magnetic circuit is inversely proportional to the, what is the energy density formula? Energy density in the magnetic field is equal to 1 by 2 into B dot H. So, read out the options here: inversely proportional to the magnetic flux density, directly proportional to the absolute permeability, directly proportional to the magnetic flux density, directly proportional to the square of magnetic flux density. Fine. So, how this I want to bring everything down into what is called a magnetic flux density. We know that B is equal to mu into H. Clear? So what I can do here, I can just bring this H is equal to B by mu. I can substitute here. So it is 1 by 2 into B into B by mu. So which is 1 by 2 into, it is B square by mu. Now check out the options here. It is inversely proportional to the magnetic flux density. Wrong. Not inversely proportional. Directly proportional to the absolute permeability. No. It is inversely here. No. Directly proportional to the magnetic flux density. No. There is a square is there. Directly proportional to the square of magnetic flux density. Yes, it is proportional to the B square. So option D is the correct. Let us have one more question here. So find the energy stored in the magnetic field if the current. So how much is the current given? So the I is equal to 5 amperes. Correct? Producing the magnetic flux. So magnetic flux is given. It is 2 milliweber through a coil of number of turns is equal to 500 turns. So we will go by definition here. What is the definition? Generally, what is the energy is equal to in the inductor 1 by 2 L I square. Okay. So we will go by the definition. What is the definition of L? Is the total flux divided by current. Yes. So what is the total flux? N into the flux through the each turn divided by I. So 500 turns into the flux through the each turn is 2 milli. 2 into 10 to the power of minus 3 and divided by the current flow is 5 amperes. So which is L is equal to 0.2 Henry. Then what is this W? 1 by 2 into 0.2 into I square. What is the I? It is a 5 square. So it is 0.1 into 25. So it is 2.5 joules. 2.5 joules. So what is the answer here? Option A is answer. Option A is answer.